Hey guys, and welcome back to another GCSE Maths video. So a few days ago we uploaded the AQA, so everything you need to know for AQA GCSE Maths, and now we're going to do Edexcel Maths. So if you're doing Edexcel, this is the exact place you want to be. Now before we get into the video, I just want to say that this video would be good for anyone doing higher or foundation tier, okay? So I've marked in bold all of the higher tier spec points, and the stuff that's just in normal font like this is for both higher and foundation. So if you're doing higher, you need to know everything in this video. If you're doing foundation, you can ignore anything in bold. We just want to go through and do some example questions. Please keep in mind that for the majority of topics here, especially the more tricky ones, I've got live lessons on my YouTube channel already in a playlist for you. So if you do get stuck, you can go and have a look at those just to kind of refresh yourself. But without further ado, let's just jump straight in. So for the first kind of spec point, you just need to be able to order positive and negative integers, decimals and fractions, and use the symbols equals to, not equals to, greater than, less than equal to, and greater than equal to. So if we were to put these numbers in order from smallest to largest, you cannot compare them unless they're all the same type. So either they're all numbers, or they're all fractions, or they're all decimals, okay? Now, in my opinion, the easiest thing to do would be to change this all into fractions, right, for obvious reasons, because the rest of these are already in fractions. And what we need to do then is, if we want to compare fractions, we need to make their denominators all the same. So to make 4 into 40, what I'm going to do is I'm going to times the top and bottom by 10. Which means I have to do the same to the top number, because whatever you do to the bottom, you do to the top. And we're going to do the same thing with this one. So that gives me 30 over 40, and that gives me 28 over 40. Now to change a decimal into a fraction, all you need to do is put the digits here, and in this case we're going to make it over 1000. Why? Because if you look, there are 3 digits after the decimal point, which means we need to put 3 zeros on the end of the 1, okay? And then all we need to do is continuously kind of divide this down. So we can divide the top and bottom by 25 if we wanted to, right? Which gives me over 40, and so it would be 7 more than 28, should be 29 over 40. So now we can see exactly what kind of numbers go in what order. Now, all you need to know is that the smaller the numerator, the smaller the fraction, if the denominator is the same. So the smallest one we have here is 28 over 40, but I'm not going to write 28 over 40, you have to write the original fraction. So in this case it would be 7 over 10. And then I personally like to kind of put a line through the ones I've already done. The next one is the 29 over 40, which was 0.725. Again, you write the original, not the kind of modified version that you've done. Then it would be 30 over 40, sorry, 3 over 4, I just made the mistake myself. And then it would be 31 over 40. Okay, so just remember to write the original. The only marks I ever see get lost on this is not writing the original values. You then need to be able to apply the 4 operations to integers, mixed numbers, and fractions. So in my opinion, integers should be fine. Decimals should be okay as well. But for mixed numbers, just remember, in order to... adding is fine, you don't need to do this. But the easiest thing for you to do for multiplying and division is to change... so if you have like 4 and 2/3, right? Change it into a whole number first. So 4 times 3 is 12, plus 2 will give you 14 over 3. And then you're going to do the add or the subtract or the times or the divide, okay? And just make sure you change into improper fractions first. When you divide 2 fractions, so let's say if we have 1/3 divided by 1/2, you use KFC. The K stands for keep, so you keep the first fraction the same. F stands for flip, so you flip the second fraction. And C stands for change, which means you change the divide to a multiply, and then you just multiply the top numbers and the bottom numbers, so 2/3. Okay. With decimals, you can do a little trick. So if you have like 10.1 times 2.4, what you can do is actually just remove the decimal point and just work out the answer 101 times by 24. Once you work that out, you can actually put the decimal point back in. So since I moved this decimal point twice, right, once for each number, I'll then move it back twice in my final answer. You also need to recognize and use relationships between operations, including inverse operations, and use conventional notation for priority of operations. That sounds really fancy. Essentially, all they're looking at is bid mass. Okay, so for example, if you had something like 2 plus 3 squared minus 10 times 40, you should know which order to do these in. So actually, let me change that round slightly. Times 10 minus 40. So the B stands for brackets, so you first do any brackets that you have. So in this case we have 2 plus 3, so that would give me 5. I stands for indices, so you're going to do any powers that you have. So we have this 2 here. By the way, if you have a square root, that counts as an indice, okay? So under indices you're doing any powers and any roots as well. So we do 25. Then D stands for division, so then you divide. We don't have a divide. Then you multiply, so that'd be 250 minus 40. Then you add and then you subtract, so then lastly it'd be 210. Now you might have noticed that I've written this basically in order that you're supposed to do it, but they could have swapped this 10 and minus 40 round, in which case you're supposed to know you meant to times before you subtract. So in the original arrangement I had minus 40 times 10. You would times minus 40 and 10, which gives you minus 400, and then you subtract it. So you do 25 minus 400, okay? So you do get very different answers. These are also the questions that you see a lot on like Instagram and things like that, where they go around and people debate in the comments like, oh, which one is it or whatever, what's the answer? So now you know how to get the right answer. You just use BidMass. You need to use the concepts and vocabulary of prime numbers, factors, multiples, common multiples, highest common factor, lowest common multiple, prime factorization, and product notation. That's a lot of stuff. So a prime number only has 2 factors. So we should probably talk about what a factor is first. So a factor is a number that can divide into another number and leave no remainder. So if I gave you the factors of 16, I would say what numbers can divide into 16 with no remainder? Well, 1, 2, 4, 8, and 16, right? Because 16 divided by any of these numbers gives me a whole number. So prime numbers only have 2 factors. So your prime numbers are just going to be 2, 3, 5, 7, 11, 13, ... going on for a really long time. Now you might notice that 1 isn't a prime number. Why? Because it only has 1 factor, which is 1. So for the rest of this, we're actually going to essentially do it all in one go. So using product notation and prime factorization, because that is exactly how we work out highest common factor and lowest common multiple. You do a factor tree. So you take 75 and you're going to break it down. So you have 25 and 3. So you're just looking for numbers that times to give me 75. Now 3 is a prime number, so I'm going to circle it because I can't break it down any further. But 25 I can write as 5 and 5, which again, they're prime numbers, so I can't write them down any further. So in other words, 75 can be written as 5 squared times 3, because there's 2 5s and there's a 3. Now what about for 105? I do the same thing. I could divide it by 5, and that would give me 11. No, it wouldn't. Give me 21. Okay? The way I divide by 5, by the way, is I divide by 10 and then double it. 5 is a prime number, so I'm going to circle it. 21 can be written as 7 and 3. So I'm going to circle it. So how do I work out the highest common factor? Well, what I do is I write down the numbers that are common. So we have 1 5 that's common, and we have 1 3 that's common. So I just do 5 times 3, which is 15. So that's the biggest number that goes into 75 and 105. Now, working out the lowest common multiple is a bit more spicy, and just so you're aware, for this question I'm going to use a calculator just to make my life easier, but you should be able to do this without a calculator as well. So, how do you do the lowest common multiple? Well, you do the exact same thing. But before we go on, I want to say that when I write things in this indices notation, that is what prime factorization is, because you're writing it as a factor of prime numbers. So all of these are prime numbers. You do the exact same thing. 120, break it down. So 10 might be a good one, and 12, 5 and 2, 4 and 3, 2. And then I'm going to circle all the prime numbers. So essentially I've got 5 times 2 to the power 3 times 3. And what about 144? So by the way, the lowest common multiple, just before we go on, is the lowest number that 120 and 144 are both factors of. So with a multiple, let's say the multiples of 3, they're just the 3 times table. Okay? So when I say the lowest common multiple, it is the smallest number that's in the 120 and 144 times tables. So I'm going to divide this by 2 first, because I'm a coward, and that would be 72. Divide by 2 again, which gives me 36. Divided by 6 and 6. 3 and 2. 3, 2. Here we are. So this would be 2 times 2 times 3 times 3. Now, here's where the lowest common multiple can get a bit tricky, right? So if we did the lowest common factor, we have, actually I'll write it in terms of prime factorization. We would do 2 cubed multiplied by 3, because that's what's common between these two things, right? That would give me the highest common factor. So that would be 24, which makes sense, right? So how do I do the lowest common multiple? What you do is I can see that these 3 2's and these 3 2's are all common. So I'm going to write that out. It's 2 times 2 times 2 times 2 times 2 times 2. All 6 of those 2's are in each of these. Then I write down that there's a 3 common, so times 3 times 3. Okay, so I've gotten rid of these 3 2's and that 3. Now I write down any other number, only a single copy of it that appears anywhere else. So 144 has no other factors, but 120 has a factor of 5. So I'm going to times that all by 5. If it was 5 squared, I would still only times by 5. Okay? Anyways, let's go. So we have 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 5, which is 2,880. So apparently that is the lowest number that appears in both the 120 and 144 times tables. Now, of course, the other way to do lowest common multiple is to go up in your times tables, but you'd have to get all the way up to here, which is not fun. You need to be able to do systematic listing strategies, including the product rule for counting, i.e. if there are m ways of doing one task, and for each of these there are n ways of doing another task, and the total number of ways is m times n. So systematic listing strategies, they may say something like, you have 3 red counters, 2 blue counters. And what I'm going to do is I'm going to take 2 out. How many different ways can I get 1 red and 1 blue, right? Or something along those lines. So with kind of the higher tier stuff, which is what's in bold, you should know that if there's 3 red counters and 2 blue counters, if you times that together, there are 6 possible ways to get a red and a blue. How do we do that in terms of listing? Well, if I label the red counters R1, R2, R3, and these ones B1, B2, then the way I'll list it is I'll start with R1 and I'll just write both of the other ones, both of the blue counters next to it, and then I'll do the same for R2. Do the same thing for R3. And if you notice, that gives me 6. Okay? So with foundation, you're only ever going to be asked to write down all of the possible combinations. So keep that in mind. For higher, they may give you something like there are 50 red counters and 400 blue counters. How many different ways can you do this? In which case you aren't really expected to list out the, 20,000 different ways of combining them, right? You're going to just instead work it out using product rule for counting. Use positive integer powers and associated real roots, square, cube and higher, and recognize powers of 2, 3, 4 and 5, estimate powers and roots. Okay, so there are some values that you're supposed to know. So you should know your squareds, so 1 squared, 2 squared, 3 squared, all the way up to about 15 squared. Okay? And that's going to be 1 and 4, 9. So what I would recommend doing is writing these all down on a little post-it note and keeping it in front of you. And then whenever you see these kinds of squares, just doing them in your head instead of referring back to that. With cubes, they're a little more lenient. So you have 1 cubed, 2 cubed, 3 cubed, 4 cubed, and lastly 5 cubed. So that's going to be 1, that's 8, that's 27, that's 64, and that's 125. Up to powers of 4, so we have 1 to the 4 obviously, and then 2 to the 4, very rarely 3 to the 4, but I'm going to put it there anyway. And lastly to the power of 5, they only really expect you to know 1 to the 5 and 2 to the 5. Okay? And again, you can use a calculator just to work these out for the first time, but then these are the ones they expect you to know. And then it says estimate the powers. So what they might do is say, okay, so what is square root of 97? And you should know that because 10 squared is 100 and 9 squared is 81, since it's closer to 10 squared than it is 9 squared, the answer is going to be approximately 10. Okay? Just less than 10. Calculate with roots and with integers and fractional indices. So the fractional indices part is entirely higher tier. So calculating with roots and integers, essentially, for foundation guys, you just need to use this. And the reason why it's a separate spec point is you also should be able to do this on your calculator. So just to kind of go through how you do that, the power button, so this is just squared, obviously, but this one gives you any blank power, so you can do to the power of like 12 if you wanted to. So that's a big number, but yeah, okay. For higher tier, again, remember that this tends to come up on the non-calculator paper, but I would like to again remind you, in fact, I'm not sure if I said this at the beginning or not, that your spec specifically says it's not broken down into the 3 papers. So a lot of the time people will say paper 3 is statistics, you know, this kind of stuff is a paper 2 topic. And they might be right, statistically speaking, they're more common to come up in paper 2 or 3 or 1. But technically speaking, any topic, any of these spec points can come up in any paper. Okay? So just keep that in mind. So how would I approach fractional indices? Well, there are 3 main components. You're going to potentially have a negative sign, and you're going to have a numerator and denominator. 3 pieces, so there's 3 steps. If you have a negative, do that first. Okay? Or at least that's the way I do it. What the negative does is it causes you to flip whatever this is. So if you have something like 2 over 5 to the power of minus 1, that becomes 5 over 2. When it's a whole number, it just becomes 1 over whatever the thing is. And that's still to the power of 3 over 5. Now, what the fraction means is you're going to take the 5th root of this and then to the power of 3. That's what it's saying. Okay, so you're doing 32 cubed and then taking the 5th root. However, you can do them in whatever order you please. In my experience, it's always easier to do the denominator first, because then it makes the number smaller, which means you can work it out, especially on a non-calculated paper. 32 cubed, sure you can work that out, but then could you work out the 5th root of whatever 32 cubed is? I doubt it. So 32 to the power of 1/5, if you look back at the values I gave you, that is actually going to be 2 to the power of 5. So it's going to be 2 in this case. So that becomes 1 over 2 cubed, and 2 cubed is just 2 times 2 times 2, which is 8. So that's how I would approach it, and you literally do get 1 mark for each of these steps normally. With the next one, you need to be able to calculate exactly with surds. So hold on, before I go on. Fractions and multiples of pi, that is just foundation, so foundation and higher I should say. Surds, simplifying surds and rationalising denominators, is solely higher tier. So calculating exactly with fractions and multiples of pi, it just means you should be able to leave your answer in terms of pi. In fact, a lot of the time, if I do like 3 pi, it will just give me 3 pi as an answer, right? So if I did like pi r squared, so pi times 9 squared, it usually just gives me it in terms of pi. Okay. So simplifying surds and rationalising the denominator. So if I type in, let's say 1 over root 2 on a calculator, you might notice if I just press equals, it changes the answer, despite the fact that I haven't actually done any operations on it. That's because you cannot have a square root of any kind, so a cube root as well technically works, fourth root, etc., in the denominator of a fraction. Why? Because this number goes on forever. So 1 divided by a number that goes on forever it's not normally done. It's a bit naughty, okay? So what you're going to do is get rid of that. How do you do that? All you do is times the top and bottom by whatever that surd is. So let's try this question here. Simplifying surds works like this. So you can write that as a product of two numbers. You can write 150 as a product of two numbers. Now I want to pick a square number because I can square root it. So the square number I'm thinking of is 25. And 25 times what gives me 150? 25 times 6. So that can be written as square root 25 square root 6. What's square root 25? It's 5. That is what they mean by simplifying a surd. Okay? So this whole thing can be written as 5 root 6 minus root 6 over root 2 times root 3 is just doing this backwards. So it becomes square root of 3 times 2, which is 6. Now I can actually cancel out everything, but actually first of all I'm going to do 4 root 6, because when you subtract you can just subtract them. So those two cancel and the answer would just be left as 4. So in this case I didn't have to rationalise the denominator, but if I wanted to I would just times by the square root, and that would automatically get rid of said square root. Okay, so now we're on to calculating with and interpreting standard form, where so in terms of a times 10 to the power of n, and keep in mind with standard form you have to have the first number to be between 1 and 10, not including 10. So here's how you do the working out. So if you are to add the two standard form numbers, all you do is turn them into ordinary numbers, add them using column method, then turn them back. Subtraction, do the same thing. But with with timesing and dividing, you can do something quite interesting. And this works for both of them, by the way, so for timesing and dividing. You can actually treat the two parts of standard form separately. So you can do the 1.8 divided by 3 first, which gives me 0.6. And then you can do the times 10 to the 2 divided by times 10 to the minus 1, which would give me times 10 to the power of 3. Okay. So what we've done here is we've done the number part and the times 10 part completely separately, and this works for timesing and dividing. Okay. Then to turn this into a proper number, you're going to times the first thing by 10, so you're going to divide the second thing by 10, which gives us 6 times 10 to the power of 2. And this is give your answer as an ordinary number, so that would just be 600. Perfect. If it said standard form, it would be the top one. So for foundation, you need to be able to work work interchangeably with terminating decimals and their corresponding fractions. So a terminating decimal is a decimal that has an ending. So what that means is it doesn't have a recurring symbol. So all of these are terminating decimals, okay? So long as they don't have the dot above one of their decimal places. And if you're higher, you need to be able to change recurring decimals into their corresponding fractions and vice versa. There are a few different ways to do this, but one of the most important ways to change fractions to decimals is you can just use the bus stop method. So 5 is going to be under the bus stop, 6 is going to be outside. 6 into 5 doesn't work, so I'm going to put that, and then we're going to add a few zeros. What's the remainder? Well, it's 5. 6 into 50, well, we can get all the way up to 48, so 6, 12, 18, 24, so that's 0.8. And like I said, that gives us up to 48, so that's the remainder 2. And then again, 6 into 20, that's going to be 3, remainder 2. And again, that's going to be 3. And as you can see, it's going to recur. So as a recurring decimal, which is 0.83 recurring. Okay, so changing fractions into recurring decimals is pretty it's not too bad. You just use the bus stop method, and once you see that you're just going to get the same thing over and over again, you stop and put a recurring decimal. And changing it the other way, I have a bunch of examples on the channel. You need to identify and work with fractions in ratio problems. So A is half of B. So that just means A is equal to half B. Whoops. Like that. Or in other words, 2A is equal to B. So what we can say here is that, in this case, A to B, or B to A, B to A would be 1 to 2. So since we're trying to do A to B, we're just going to do the exact opposite of that. It's going to be 2 to 1. You also need to interpret fractions and percentages as operators. So what that means is, if I say a half of 40, it means the same thing as half times 40, and likewise 10% of 30 is an actual kind of operator in itself. So what they mean by an operator is that you can actually do some maths with it, right? So times, divide, subtract, and square root and squaring, they're all operators. So you have to also realise that fractions and percentages are also operators. So half of 40 is a valid thing to say in terms of maths. Using standard units of mass, length, time, money, and other measures. So mass will be mainly kilograms and grams. Length could be quite a few different things. You have millimeters, centimeters, meters, kilometers, and that's probably the main ones that you're going to be given. Time, there's a lot of these: seconds, minutes, days, hours, months, weeks, etc. Money, really the standard unit of money in this country anyway is pounds. And other measures, so standard compound measures, things like meters per second or miles per hour for speed. Pressure would be newtons per square meter or pascals, and things like that. You need to also do estimation. So it says here you need to check calculations using approximation and estimation. However, there are two styles of questions they can give you. So one of them is, hey, use approximations to estimate this. The other style is, some person, Johnny or Suprino or something, works out this to be equal to something, using approximations to check if they're right. But as you can see, it's actually the same question twice, right? All you're going to do is use approximations. Now, whenever you see the word estimate, I want you to round to one significant figure, okay? Now, there are multiple ways of doing these estimation questions, right? Like picking like a number that will be useful to you and then rounding it to that. But I think that there's too many decisions to make, right? And then some students get paralyzed by that. In an exam, they're like, oh, what if I rounded it to the wrong thing? I'm panicking. Here's a hint that I'm going to give you. If you always round to one significant figure, you will always be correct, okay? So don't forget they do give you a range of answers. This will always get you in the range. So root 97, one significant figure becomes root 100. 2.014 is just going to be 2 cubed, and that's going to be 0.5. Square root of 100 is 10, 2 cubed is 8. So then we have 18 over 0.5. That's the same as dividing by a half, which is the same as timesing by 2. So that would be 36. If you don't believe me, here is how I'll do it. 18 over a half. So that's the same as 18 divided by a half. Keep flip change, keep the first thing the same. Flip the second thing and change to times. So that would indeed be 36. Okay, so a few different ways that you can work that out. You should be able to round numbers and measures to an appropriate degree of accuracy. So just rounding basically. The number of people living in a town is 47,000, the nearest 1,000. Which of these is a possible number of people living in the town? So what we're going to do, in my method for this, is to round all of these answers to the nearest 1,000. So this one to the nearest 1,000 is just going to stay the same, right? 46,000. Because the number after the thousands column is 0. Same thing here. Well, it's 5 or above, so we round up the thousands column. Right? So we know that this could be one of our answers. But to keep going, again, thousands column, the one next to it is a 5 or above, so we round up. So that'd be 48,000. And again, this one would be 48,000. So yeah, the only answer would be the second one along. Okay. Moving swiftly on, we're almost at the end of the numbers section, so that's nice. Apply and interpret limits of accuracy, and then for higher tier, including upper and lower bounds. So, to be honest, these are very similar here, okay? So, when we do error intervals, what we're saying is, when we've rounded this to 3 significant figures, we're looking for a number, right, that has more decimal places, right, that will round to 6.37. And we want to get all of the values, right? So we can either write an infinite number of numbers, which sounds like it would take a while, or we can use good old-fashioned inequalities. So here's what I do. I take the lowest decimal place, right, which in this case would be a 0.01, right? Because if you look, there's so in this case 6.37, there's 2 values before it, so 0.01, and I'm going to half it, which gives me 0.005, and I'm going to add that and subtract that from 6.37. So that gives me an upper bound of 6.375 and a lower bound of 6.365. So I'm just looking for the ones that have these two as our values, which again you can just see would be this one here. And if you notice, some key things right here is that it's a less than equals to sign, because don't forget the value can equal 6.365 because that would round up to 37, but it's not equal to 375. Why? Because if it equals 375, it'd round up to 38, right? So we're talking about it's very close to 375, but it's actually just a tiny bit smaller than that. It's all the way up to it, and that leaves us with that's us leaving the numbers section. So now we're going to do algebra. So this is a very meaty section as well, but on the bright side, the 4 after this are actually pretty short. Well, in comparison anyway. I think there's about 20 topics for algebra. So you need to be able to essentially use all of these, okay? So this is the basics of algebra: ab instead of a times b, 3y instead of y plus y, and so on. So some of the questions you can expect are things like this. So circle the expression that is equal to x plus x plus x minus x plus x. So what I do is I just add these up. So 1, 2, 3, 4, but then there's a minus 1, so it makes it back down to 3. Okay? So, yeah. And with this one, this is actually a very interesting question because a lot of students would have gotten this wrong. So Lucy says she wants to simplify this, and she writes 4a minus 7b, which we need to check if it's correct. So here's what I would do. I would actually work out what it would be. Now when a minus is outside the brackets, or if anything's outside the brackets, you times everything inside the brackets by whatever's outside the brackets, but only if it's touching. So can you see this minus is actually touching the bracket here? Okay? So instead of 7b, it's going to be minus 7b. Minus 2a, but then there's also a minus here, so it's minus minus 2a, which would give me plus 2a, which equals 8a minus 7b, which is not the same as what she wrote, so she is not correct. And the reasoning is just you writing this out. Okay? You need to also substitute numerical values into formulae and expressions. Okay? So, again, when you substitute something, you're given some kind of expression or formula, and they'll tell you what each letter represents. In this case, we only have one letter. Okay? So, everywhere I see a in this expression, I'm going to replace it with 10 in brackets. So instead of a, I'm going to put 10, and the squared is still there because I'm only replacing the a. Minus 4 times 10. Make sure you use brackets because, again, even sixth form students make mistakes when they substitute numbers in, believe it or not. And again, even on your calculator, use brackets because calculators can be a bit stupid sometimes. 10 squared is 100, minus 4 times 10, which is 40. So my final answer is 60. Nice and easy. Understand and use the concepts and vocabulary of expressions, equations, formulae, identities, inequalities, terms, and factors. So, factors we've actually already been through in the numbers section, but it's just something that will divide into something else and leave no remainder. A term is just either a number, a letter, or a number and letter next to each other. So 3a and 4x and even x squared are all terms, okay? They exist completely by themselves, there's nothing else with them. An expression has 2 or more terms, okay? So, for example, you could have 4 plus x, you could have 4x plus y, and so on. The key thing with expressions is that they have a term and an operator, and then obviously they're going to need some other kind of term as well, right? Well, I guess not always, but essentially they need to have a number and an operator, okay? So a term and an operator will make an expression. So generally speaking, you have two terms and an expression between them. An equation has to have an equal sign in it. So for example, 4 plus x equals 7 is an equation. The EQUA part basically just stands for equal, okay? Now a formulae is an equation. However, it calculates something that exists in the real world. So what I mean by that is, for example, the formula for speed is distance over time. Now this is also an equation, but the reason why we call it a formula is because it calculates speed, which is some quantity. So for example, area would also be an equation, a formula, and same with volume, density and things like that. So it's an equation always, but it's a formula if it specifically calculates something that's useful. So for example, everything in science that you calculate is a formula because it has an actual real world application. 4 plus x equals 7 it doesn't correspond to a real thing, right? It's just a number. Inequalities is when you have an inequality sign, shockingly. So you can have anything like this. That's all inequalities. And that is the last thing. Identities is a bit more interesting. It shows a relationship between two different values. So for example, you may have, with identities, you don't really have that many in GCSE Maths, but one of them could be tan x is equal to sine x over cos x, as an example. Any of you, for some reason, looking at this when you're doing A-level maths, you also have all of the kind of sine, cos and tan formulas that you need. Okay, simplifying and manipulate algebraic expressions, including those involving surds, and algebraic fractions for higher tier. So collect like terms, multiplying over a single bracket, expanding the products of two or more if you're higher tier. Binomials. Binomial just basically means when you have two brackets like this, right? And factorising quadratics. So let's just go through all of this. So when you multiply out, I mentioned before that what you need to do is everything outside the bracket that's touching, right? So sometimes I'll see students do 5x plus 3x minus 2, and they'll actually expand the bracket. That's not what you're supposed to do, right? It's just the stuff that's actually touching the bracket. And what this will do is it will times everything inside the bracket. So 5x times 3x, well 5 times 3 is 15. X times x is x squared. And then you also have 5x times minus 2. Well, 5 times minus 2 is minus 10. And then you just have an x left over. Now, factorising is the opposite of multiplying out or expanding, depending on what vocab you want to use. What you're looking for is something, the biggest thing you can take out of or divide 50x and 100 by, which is, of course, 50, which leaves me with x. And then I'm asking myself, what do I times 50 by to get 50x, which is just x. And then what do I times 50 by to get 100? That's 2. When you have a quadratic, it's a bit more spicy than this because you can't actually pull out. It's not obvious what you can take out anyway. Of course you can, but it's not very obvious. So what you do is you're looking for two numbers that multiply to the end number, the 10, and add to give 7. So that would be 5 and 2, and you shove those straight into brackets. So x plus 5, x plus 2. Now this is mainly for, well, this is actually entirely for higher tier. However, before you foundation guys turn your brains off, I'm actually going to show you how to expand to binomials, because that's how you expand 3 binomials, funnily enough. So all you need to do is, can you see all of this stuff here in the first bracket is basically touching this bracket because it's inside brackets by itself. So you need to make sure that everything in this first bracket multiplies everything in this second bracket. So x needs to times x and 4, 2 needs to times x and 4. So you should get 4 things, okay? Now, of course, that might be tricky to remember. So I'm going to show you another method Well, it's the same method, but it's just a way of remembering to multiply absolutely everything, and it's called FOIL. Okay? F stands for first, so you multiply the first term in each bracket. So that's x times x, which is x squared. O stands for outside, so you're going to multiply the things that are on the outsides of both brackets, so that's x times 4, which is 4x. I stands for inside, so you multiply the two terms on the inside of the bracket, which is 2 times x, so 2x. And L stands for last, so you multiply the last two things in the bracket, which gives me 8. So can you see I've got 4 terms, as I said. Now, that's all you need for foundation, so now you can turn your brains off. For higher tier, this is how I actually expand 3 brackets. Okay? So you take 2 brackets and expand those. Then you simplify. So x squared stays the same, but then you have plus 4x plus 2x, that's plus 6x, and then plus 8. And now what you need to do, and this is where things can get very tricky and very easy to make a mistake, you're going to expand these 2 brackets. However, if you notice, you should get 6 terms, because x squared times is x and 1, 6x times x and 1, 8 times x and 1. Okay, so basically it's easy to miss one out. So x squared times x gives me x cubed, x squared times 1 gives me x squared. And then what I do is I tick it off. Okay, so now I know I've done all of those. Okay, and again, just so you remember, you should get 6 terms after you expand, before simplifying. So if you simplify in your head, then obviously you won't get 6 terms. 6x times x is 6x squared. 6x times 1 is 6x. Tick it off. I will also say, a quick tip with this, is make your work neat. Okay, I know that my handwriting isn't the best, but everything's laid out very specifically, which makes it very hard for me to make a mistake. I've seen some of your guys' handwriting, and your maths is all over the place, and obviously you're going to miss something, right? So be really careful with that. 8 times x is 8x, and then 8 times 1 is 8. So can you see I've got 2, 4, 6 terms, so I know I'm correct. Well, at least I know I've times everything. Then we gather like terms. So x cubed, there's no other x cubed, so I'm going to put that there. And what I would do in the exam is I'll then put a light line through the x cubed to show I've done it. But you know, if you use your pen very lightly, it comes out quite faint. If you do like a hard crossing, the examiner will assume you don't want it marked. So just do it very lightly. Since I can't do that because this is a graphics tablet, it doesn't allow me to put different pressures really, at least this one that I have. I'm just going to tick them off instead. Then we have x squared. Do we have any other x squareds? Yep, we have 6x squared. So that gives me 7x squared. So I'm going to tick those guys off. Then I have x's. I have 6x and 8x. So that gives me 14x. And then lastly I have the plus 8 on the end. And that's it. That's all we have to do. Now here we have another factorising, but if you notice there is a number in front of the x squared, which makes our life a bit harder. Instead of looking for 2 numbers that times to 2 and add to 5, I'm looking for 2 numbers that times to 4, because I multiply the first and the last numbers. So times to 4, add to 5, which is of course going to be 4 and 1. So now what I do is, instead of having 5x, I'm going to have 4x plus x, which as you can see will simplify back to our original question, which is good because that means I've done it right. I then divide this thing in twain, in 2, and I factorise the first 2 things. So 2 and 4, what's the biggest common factor? Well, it's 2, right? And then x squared and x, all you do is you pull out the smallest power of x, which in this case is just x. Open bracket. What do I times 2x by to get 2x squared? I times it by x. What do I times 2x by to get 4x? I times it by 2. Now, I factorise the latter bit, and you might notice I can't actually pull anything out. But for this second half, if you can't pull anything out, you have to pull a 1 out. So I'm going to put plus 1 and then the same thing. The reason for this is I need to have 2 brackets. And now here's where you can do your first check to see if you're correct. Well, actually, the first check is actually making sure this simplifies to the top thing. And you can do the same thing here, see if this simplifies to the top thing as well. But a much quicker way is these two brackets must be the same. If they aren't, you factorize something wrong, okay? Now, what my two brackets are, the duplicate bracket is one of the brackets, x plus 2. And everything in front of the brackets is the other bracket. And that's your final answer. Nice and easy, hopefully. You also need to use mathematical formulae and also rearrange to change the subject. In terms of the ones that we need to use, they're going to come up throughout this video. So for example, you may need to know some areas. That's coming up in the geometry section, right? And compound formulas as well is coming up a bit later. So I'm not going to go through them now, we're going to go through them a bit later. So making you the subject, well, all you need to do is when you make something the subject, it's going to be u equals and then a bunch of stuff, right? So all you want to do is make u by itself. So what's stopping the u from being by itself is this plus at. So you do the opposite. What's the opposite of plussing at? Minus at. So you have u is equal to v minus at. That's it. Now, we also have making x the subject the formula, and if you notice there's two x's, which immediately sets people into a panic. So I'm going to show you what you need to do there. But in general, my order of like operations, if you'd like, for rearranging is I get rid of any brackets, then I get rid of any fractions, and then I rearrange, okay? So, I don't have any brackets, but I do have a fraction. Now, how can I get rid of any fraction? You times it by its denominator. So if I times this side by x plus 2, that fraction deletes itself, okay? You're just left with the numerator. So a half times 2 is, 1. A quarter, 3/4 times by 4 is 3, and so on. Now, of course, because rules of algebra, whatever I do to one side, I must do to the other. So we have a x plus 2 was x plus 4. And remember what I said? Any brackets, we terminate with extreme prejudice. So ax plus 2a was x plus 4. Now you're probably thinking, okay, I've got x's on both sides and I can't actually combine them, right? Well, here's what you do. If you ever have multiple x's, here's what you do. Move all the x's to one side and everything else to the other. So any term that has an x in it, move to one side. So I have ax here, I'm going to move this x to the other side, which means I need to move the 2a to the other side. So we have ax minus x, because I have to minus x on both sides, equals 4, and then minus 2a, because we want to get rid of the plus 2a on this side. Now what I can do is actually factorize out the x, which means I now only have one x, and then all I want to do is divide this down to the other side. So we have x is equal to 4 minus 2a over a minus 1. Nice and I would say fun, but I don't want to lie to you. Okay, so yeah, we need to know the difference between an equation and an identity, so we've already kind of done that. And for higher tier, you need proofs. So proofs can come in like a billion different kind of configurations. However, I do have a full live lesson on the channel where we go through proofs all the way from the easiest all the way to the most kind of complicated. So if you're a bit stuck on that, I'd recommend going to watch that, of course. But as a quick example, prove algebraically that the sum of any two consecutive integers is always odd. You need to do it algebraically so it works for every single possible value. So an integer is just going to be n, right? Now consecutive means they're next to each other. So the next integer would just be n plus 1, right? So if I add those together, n plus m plus 1, I get 2n plus 1. Right? Now if you notice, 2 times any integer is always even. An even number plus 1 is always odd. Hence this expression, so the sum of any two consecutive integers is always odd. Fairly easy. And here we need to do a bunch of function stuff. So you need to, if you're foundation, you just need to interpret simple expressions as functions with inputs and outputs. So as you can see over there. However, if you're higher tier, you need to be able to do inverse and composite functions. So, top one is for foundation only, so a rule, well, and higher. A rule to calculate taxi fare is £2.50 plus £2.20 per mile. Work out how much a 10-mile journey would be. Well, it'd be £2.50 plus £2.20 per mile, so 2.2 times 10, so 22, which gives me £24.50, which honestly isn't actually even that bad for a taxi. Now, for higher tier, you need to be able to work out composite and inverse functions. So if you have a function which is just x squared minus 3, it says solve f minus 1, which means inverse function of x, is equal to 8. So how do I work out an inverse function? That's a brilliant question. I'm going to write the same thing as this, but instead of f of x, I'm going to write y. Now, a regular function takes in values of x and gives you values of y. An inverse function takes in values of y and spits out the value of x that you would have had to sub in. So we're going to rearrange for x. So add 3 to both sides, and then square root to get our final answer here. The last thing you need to do is replace x with just the inverse operation symbol, like that, and replace y with x. And that is your answer. Now we have to solve that it equals to 8, so we just have 8 is equal to square root x plus 3. So square both sides to get rid of the square root. Subtract by 3, so x 61. Now, for the functions one, or composite functions, they always operate like this, and you always work from the right to the left. So it's kind of backwards to what you might expect. Okay, so it's saying find g f of 3. What this means is you're going to find what f of 3 is, and take that answer and sub it into g. So f of 3 is 2 times 3 minus 4, right? Because that's what f is. 2 times 3 is 6, minus 4 is 2. So gf of 3 is equal to g of 2, because I've worked out what f of 3 is, and I'm going to sub it into g. So 3 times 2 plus 5. So that's 6 plus 5, which is 11. Cool. Easy as pie, hopefully. You need to work with coordinates in all 4 quadrants. So what that means is you should be able to recognize that if you have an axis like this, right? If you have two positive numbers, let's say 2 and 2, then you're going to go 2 across. So, 2 across and 2 up. So it'd be somewhere in the first quadrant up here. If you had something that was minus 3 and 4, then minus 3 is over here, 4 is up here. And then here would be 2 negative numbers, so minus 3 and minus 7 or something like that would be in the bottom left. And in the bottom right you have a positive number followed by a negative number. You just need to be able to kind of work with those coordinates. You also need to plot straight lines and also identify parallel and perpendicular lines. So first of all, plotting straight lines, there's a few things I can do to kind of help you out with this. The first thing is all you're doing in this table is substituting in these x values. So x is minus 2, what would this become? Well, it becomes y, 4, minus 2, minus 4. 4 times minus 2 is minus 8, minus another 4 is minus 12. And then you do the same thing for minus 1, right? Y is equal to 4, minus 1, minus 4, which is, whoopsies, which is minus 8. And then 0 would be minus 4. Now that might, that seems a bit tedious. However, there is a trick I can show you. The number in front of x is called the gradient, and it tells you how much y changes for each value of x. So, can you see the difference between all of these numbers is adding 4 each time? All you need to do is look at the number in front of x and add that each time. So if it's a minus number, you subtract it each time. If it's a positive number, you add it. So it'd be 0, 4, and 8. Don't believe me, you're more than welcome to double check my answers, and hopefully I haven't got it wrong. I'm kidding. Then to plot it, each of these makes a coordinate, right? So minus 2, minus 12, then you have minus 1, minus 8, and so on. So minus 2 is minus 2 along, and minus 12 down, so that would be over here. Minus 1, minus 8 would be here. 0, minus 4, 1 and 0, 2 and 4, 3 and 8. And then what you do is draw a straight line going through those points, okay? Okay, a perfectly straight line. But it should go through all of the points. Use a ruler, of course. And you also need to identify parallel lines, and if you're higher tier, you need to identify perpendicular lines. So parallel lines are two lines that will never ever meet, ever, ever. And the way you tell is you look at their gradients. So parallel lines have the same gradient. And if you remember, when you have y equals mx plus c, the number in front of the number in front of x, which is m, is always the gradient. So as you can see, these guys both have the same number in front of x, which means they have the same gradient, which means they are parallel. Okay? Now, of course, you need to be careful if you have something like 2y equals 2x plus 4. That is not parallel. Why? Because there needs to just be y equals. We have 2y equals, so we need to divide both sides by 2. So in actuality, it's this equation, which of course isn't parallel. For perpendicular lines, their gradients are the negative reciprocal. So if I have y is equal to 2x plus 2, the perpendicular line would have to be flip it, so a half, make it negative, and that will be kind of the perpendicular line instead. We now need to identify and interpret gradients and intercepts of linear functions graphically and algebraically. So I showed you how to do that algebraically just now. So this question, the intercept would be right here at about 0.5. Now how to work out gradients? Well, what we can do is if we take 2 points, ideally that end on like the corner of a square, we can look at we just make a big triangle. And you see the width of this triangle is from -1 to 5, so that'd be a width of 6. And the height is how many boxes? 1, 2, 3. Then all you do is you divide the height by the width. That gives you the gradient. How easy is that, right? The only thing you have to consider is which direction the line's going, okay? If it's going up like that, it's a positive. If it's going down, it's always negative, okay? So the only thing you need to do is add a minus or leave it as is if it's going upwards. You need to identify and interpret roots, intercepts and turning points of quadratic functions, deduce roots algebraically and turning points by completing the square. So, for completing the square, here's what you do. Here's the equation, right? So if your general equation is x squared plus bx plus c, right, as you can see, that kind of matches up pretty well. The equation for completing the square is x plus b over 2 squared minus b over 2 squared plus c. So let's sub that in. B is 14, so we're going to do x plus 14 over 2, which is 7, minus 7 squared, believe me that says squared, and then plus 52, so we have x plus 7 squared minus 49 plus 52, so we have x plus 7 squared plus 3. So the coordinates of the turning point, all you do is you take this value and flip the sign, so that's minus 7, and then you take this value and you keep the sign the same. Okay, nice and easy from turning points. Recognize, sketch and interpret graphs of linear, quadratic, cubic and reciprocal functions. So if we go through this, linear you should recognize is just any straight line graph. Quadratic is either a happy face, so a U shape, or a sad face, an N shape. But these other ones you might not have seen before. So a simple cubic will look something along the lines of this. You may also have something that looks a bit more like humpy. Humpy, that's a weird way of putting it, but hopefully you get my point. For a reciprocal function, that looks like this. Okay? And the very key point here is that it doesn't touch the x or y axes at all. Okay? So get rid of those. Delete, there we are, good. For higher tier, you need to also know the exponential function. Well, all that always looks like is this. And it never touches the x-axis, and also it always crosses at x is equal to 1. Because anything to the power of 0 is 1. You then need to know the sine, cos, and tan graphs. Well, sine starts at 0 and goes up, and it varies between -1 and +1. And if you remember, every 90 degrees it kind of changes. Yeah. The cos graph looks very similar to this. However, it starts at 1 and goes down at 90, down to -1. There we are. See the concentration on my face there? The tan graph looks completely bloody different. Essentially, come on, rub out, please. Thank you very much. Looks like a bunch of like DNAs over and over again. So if I were to draw this out for you, looks like this, where this is 90 degrees, and then every 180 degrees it repeats. So here it goes down and across, and that would be at 270 degrees. Okay. Sketch translations and reflections of a given function. So for this section we need to be able to sketch translations and reflections of any given function. So if we look over here, we have a bunch of different kind of reflections and transformations that we have to do for this particular curve here. So I'm going to explain exactly what you need to do. So if it's inside the bracket, it affects the x coordinates only, and it does the opposite of what it says. So what this means is we're actually going to -3 from x, right? So I know it affects x because it's inside the bracket, and it does the opposite. So all we're going to do is subtract 3 from this value over here, which would make that -2, 4. So effectively all you're doing is moving the graph over to the left. For this one, it affects y because it's outside the bracket and it does exactly what it says. So in this case it's saying that you're going to times all the y values, so times y by -1. So the y value here is 4, so instead it's going to be -4. Again, it's outside the bracket, so it affects y, but in this case it's going to subtract 3 from y. It does exactly what it says. So that's going to be 1, 1, so it's just sliding down. And this one, this is where it gets a bit kind of weird. You're doing the opposite and affecting x, but the thing is, it's just -x. So instead of timesing by -1, you're dividing by -1, which is just the same thing. So you can say just times x by -1 if you'd like, which would make that -1, 4. Plot and interpret graphs and exponential graphs of non-standard functions in real-life contexts. So here we have Bernie filling up a swimming pool. It shows the volume against time. Work out the rate. So rate just means the volume per second, so you're just working out the gradient. If they ever say rate, then that would be gradient. And here it says liters per hour. That should also give you a hint that it means gradient. So all you're going to do is, again, draw your big old triangle. The width is just 20, and the height goes from 20,000, it ends up at 94,000, I believe. So all you're going to do is, actually, let's work out what it is. So the difference is 20,000 in 10, so it goes up in 2,000, as I said. Okay, so 82, 84, 86, 88, 90, 92, 94. So yeah, it goes up to 94,000, but it starts off at 20,000, which means the difference is 74,000. So then you're just going to do 74,000 divide by 20, so cross off a 0 and half it, so that'd be 3,700 litres per hour. And the other thing you should look for is whether or not it's positive or negative. So since the graph is going up, it's going to be a positive value. Estimate areas underneath graphs and also gradients if it's like not a straight line. So for this one, work at the acceleration for the first 3 seconds. That's just going to be the gradient of this first triangular section here. So the width is 3 and the height is 3 as well. So that's just 1 meters per second squared because it's 3 divided by 3. The total distance, well, this is a trapezium, right? Followed by a rectangle. So we have 2, we have 5, the width is 3, here it's 4 and height is 5. So if I label these as 2 separate areas, area of the first one is a trapezium, so half a plus b, where a and b are the 2 parallel sides added together, so 2 plus 5, multiplied by 3 plus 5 times 4. So for this one, I think I'm just going to use a calculator. You don't need a calculator to do this, and it could come up in a non-calculator exam, but just in the interest of time, because I don't want you guys falling asleep, let's just use a calculator. Again, I'm probably not going to go over the very basic kind of adding, subtracting, multiplying, and dividing and those tricks, but if you do think that would be a useful thing for you to learn, then do let me know. This should actually be down here, by the way. Cool. You also need to recognize and use the equation of a circle with the center at the given point and find the equation of a tangent. Again, this is higher tier only. So a tangent is just one that, so in this case, is the tangent at 3, 4. So that point, it's a line that only crosses the circle once. So it might look something like this. Okay, and what you do is you work out the gradient and then the points. Good thing is my bad diagram doesn't actually matter, because what we're going to do is we're going to use a circle theorem to help us. So this is the radius, and it tells me the radius is equal to 5, which doesn't really matter. But the radius and the tangents are always perpendicular to each other. So what I can do is work out the gradient of the radius and inverse reciprocal, so change it to a negative and do 1 over it in order to work out what the gradient is. So the gradient of the radius, let's call that MR, is just equal to, well, the height is 4 and the width is 3, which means the gradient of the tangent, you flip the fraction and you make it the opposite sign, so in this case negative. So y equals mx plus c. So the m at this stage is 3 over 4 x plus c. I don't know what plus c is, but I know one of the coordinates that the tangent goes through. It's 3, 4, as it says in the question. So if I say x is equal to 3 and y is equal to 4, I can sub that in to work out what c is. And this is just kind of some basic rearranging, so let's just work this out. Minus 9 over 4, because 3 times 3. So c is equal to 4 plus 9 over 4, which, remember, 4 as a fraction with a denominator of 4 would be 16 over 4, so that would be 25 over 4. So my equation for the actual tangent is going to be minus 3/4 x plus 25 over 4. Solve linear equations with one unknown algebraically. So again, you might have something like x plus 4 equals 10. So then you just need to rearrange for this. So this is very similar to the spec point which said to make something the subject of a formula or rearranging formulas. When you're solving equations, all you're doing is making the letter the subject of the formula. That's all you need to do. Solve quadratic equations. So what we can do here, it says by completing the square and using quadratic formula. So all you'd need to do is factorize this or use completing the square. So I'm going to show you since we've already done that already, I'm just going to show you the quadratic formula. A generic kind of quadratic equation looks like that. And the solutions, so the quadratic formula is just minus b plus minus the square root b squared minus 4ac over 2a. So minus, in this case, minus 7. So again, make sure you actually use your brackets, because sometimes students have just written minus 7 when this is a negative number, but it's minus of minus 7, which would make it plus 7. So just keep that in mind. And that is minus 7 squared minus 4. A is 1, C is 10 over 2 times 1. And you're going to get 2 answers. Why am I going to get 2? Well, quite simple actually, because there's this plus minus in the middle of the quadratic formula. So you're going to do it once with a plus sign and another time with the negative. Technically you do it either way, but I prefer to do it this way. Cool, so I can't press plus minus, I'm just going to put plus. And again, I'm using all of the brackets that I've placed here. Whoops. So my first answer is 5. And I'm going to change that to a negative to work out what this is, which is 2. solve two simultaneous equations in two variables, so either linear or a quadratic one if you are in higher tier, and also find the solutions using a graph. So we actually did one of these kind of earlier. On a graph, where two equations intersect will be the solutions to any simultaneous equations. So if they're two linear things, you'll have a crossing point. Those values will be your solutions. So how do you work this out? Well, when it's two linear ones, you want to make one of the letters have the same number in front of the variable. So if you have a look here, there's a 3 in front of both of these, right? And then you're going to add or subtract the equation. If they have the same sign, you always subtract. So same sign, subtract, different sign, add. These have different signs, so I'm going to add. So that gives me 5x, because 4x plus x, plus 3y minus 3y is 0, equals 25, so x must equal 5. I then sub in x into any one of the equations. I'm going to pick the first one to work out what y is. So 4 times 5 plus 3y equals 18. So that's 20 plus 3y equals 18. Subtract 20 from both sides, so 3y equals minus 2. So y is equal to minus 2/3. And those would be your two answers, here and here. You need to get a value for x and y, or whatever your two letters are. With simultaneous equations, there's always two letters and two equations. If you're higher, you may have to do a quadratic one. Now, you can't do this method here, which is called elimination. Okay? Instead, you have to use a new method called substitution, which does work for linear ones. It just tends to not be easier. So all you're going to do is you're going to take this equation and sub it into this first one and then solve it. So y squared, expand and simplify. It's 13. Move, collect all the like terms. So you have 2y squared minus 10y is 25. Now, to solve quadratics, you need to make sure they equal 0. So we're going to minus 13 from both sides to get rid of that. 10y is 12. Divide through by 2, and we get y squared minus 5y plus 6 equals 0. Now, we're going to solve this. You can do it by factorising. You can do it by quadratic formula. You can do whatever you want. Factorising, you could use minus 3 and minus 2, so let's just use that. And you might notice that we're actually going to get two separate solutions. We're going to get y equals 3 and y equals 2. Now, the thing is, in a quadratic simultaneous equation, you're going to get two y values and two x values. So I'm going to sub this y value into this equation here, which just says that x is equal to, in this case, 3 minus 5, which is minus 2. And you need to make sure that your x values match up. So don't write the x value for this y value over here, because otherwise it won't be correct. And again, so that would be 2 minus 5, so that would be minus 3. So we have two pairs of values here and here. Okay, so you need to get 4 answers essentially. Okay, so now we're going to move on to iteration. So iteration is a higher only topic, and it tends to be called a calculator only topic. But again, just to reiterate what I've said before, get it? Any topic can appear in any paper, okay? But I'm going to show you how to do this with a calculator really quickly, because most of the time it does appear on calculator. If it doesn't appear on calculator, you can just do this by hand manually. So here's how I do it. You take whatever the 0 thing is, so P0, T0, whatever. You just type it into your calculator and press equals. What that does is it saves the answer as the ANS button. Now you're going to write this exact expression again, but instead of the PT, or whatever the letter is in your case, you put the ANS button. Again, if it appears multiple times, you do the same thing. Now, every time you press equals, it's going to re-change what the ANS button is. So, in 1 day, it's going to be 230. 2 days, 241.5. 3 days, 254.725. That's how easy iteration can be when you use a calculator. So the answer is 254.725. However, let's use our logic for a second. It says the number of rabbits. Can we have an like 0.725 of a rabbit? Maybe it has like 1 ear or something? No. So we're going to round this up to 255. Okay? Because keep in mind it is an estimate, so it is meant to be slightly off. And yeah, that's all you need to do for iteration. Translate simple situations and procedures into algebraic expressions, and therefore you need to be able to do that for simultaneous equations and interpret the solution. So here we have a situation: 2 coffees and 3 cakes cost £9.95, 1 coffee and 4 cakes cost £10.35. Work out the price for a coffee and the price for a cake. So if we assign the letter C for coffee and K for cake, because we don't know what their values are, we can create some simultaneous equations. 2C plus 3K, we just screw over, equals 9.95. And then we have 1C plus 4K equals £10.35. Now, because the numbers aren't the same, and we know that we need to make the numbers in front of one of the letters the same, I'm going to think, what's it easier to do? Make the C's the same or the K's? Well, the C's, because all I have to do is times this equation by 2. So let's write out the exact same thing again. So I'm writing the top equation exactly as it normally is. Then the second equation would be 2C plus 8K equals £20.70. So I'm going to use a calculator for this just because I want to save us some time. So because they have the same sign, they're both positive, we're going to subtract. So we have minus 5K equals, and then 9.95, whoops, 0.95 minus 20.70, which gives me minus 10.75. Because they're both negative, we can actually cancel out the negative signs and divide both sides by 5 in order to get our answer of £2.15 for a cake. So I like to put my answers in boxes just so the examiner can see exactly what answers I got and they can just give me all the marks. Then we're going to sub it into one of the equations. This second equation here makes the most sense because C is already by itself. So you have C plus 4 times 2.15 equals £10.35. So C plus £8.60 equals 10.35. So C is equal to, let's just do it on the calculator, minus 10.35 minus 8.6. I could have definitely done that quicker in my head, which is £1.75. Okay. You also need to be able to solve inequalities in 1 or 2 variables, so 2 variables if you are higher, and quadratic inequalities, and represent them on number lines. So first part is foundation tier and higher tier. So on the number line, show the inequality x is bigger than minus 3. So we're going to put a little mark on where minus 3 is. Now if it's not equal to, you leave it hollow, but if it was equal to, you would colour that in. And then since it's greater than, it's all the values to the right, and you need to make sure you put an arrowhead because it can go on to infinity. This is also foundation and higher. You have y is less than equal to 1 is less than equal to y, which is less than 5. Write down all the possible values of y. Well, it can equal 1, so we have 1, then 2, 3, 4, and it can't equal 5 because there's no equals to over here. And keep in mind y is an integer, hence why I've done whole numbers only. And then again, solving in one variable. Essentially, I do get asked a lot, like, what happens if there's an inequality instead of an equal sign? On the bright side, you can actually treat this exactly the same as an equal sign. The only difference is that if you times or divide by a negative number, you swap the sign of the inequality. So again, I would just want t on one side by itself, so I want a minus 7 from both sides. We get 4t less than equal to 12. Divide both sides by 4, and you get t is less than equal to 3. That is your solution. Generate terms of a sequence from either a term-to-term or position-to-term rule. So here are the first 5 terms of a sequence. Write down the next 2 terms. Well, if you look, what you should do is work out what the difference is. So that's plus 2, then it's plus 3, then it's plus 4, is plus 5. So logically, it should increase by 6 next. So 16 plus 6 is 22. Then it should increase by 7. So that'd be 29. You need to be able to recognize and use the sequences of triangular, square, and cube numbers, simple arithmetic progressions, Fibonacci, quadratic, and simple geometric progressions. So, and if you're higher, the geometric progression might have a surd as the common thing. So with triangular numbers, they start at 3, and then the difference increases by 1 each time. Okay, so can you see I'm just increasing the difference by 1 each time? Okay. With the, so technically maybe 1, then 3, then so on. Fibonacci is where you add the previous 2 terms of the sequence. So in order to get 2, I had to do 1 add 1. Then I do 1 add 2 gives me 3. Then 3 add 2 which equals 5, and so on. Arithmetic just means you're adding by the same number each time. Geometric is when you times by the same number each time. So you could have something like 2, 4, then 8, and then so on. Because you're timesing each value by the previous. So you times each previous term by the same value each and every time. Deduce expressions to calculate the nth term of linear, and then if you're higher, quadratic sequences. So I'm going to show you 2 equations, and the reason why I'm going to show you equations is because they take a lot of the guesswork out of doing sequences. So I always kind of just disliked sequences when I was in school because there was a lot of guesswork. But when I got into A level, there are actually equations we can use for both of these, which make our lives a lot easier. Now, if you're finding that you can guess it really easily and it's really effective, then continue doing that. But for those of you that might be frustrated at sequences like I was, I'm going to show you a way on how you can eliminate all guesswork, okay? So, with arithmetic sequences, the equation I want to show you is this. And you'll actually come across this in 6th form more as well. A is the first term, which in this case is just 4. D is the difference between each of the terms. So it goes 4 to 11, so that's plus 7, plus 7. So I know it's an arithmetic progression, for sure, and the difference is 7. So if I sub that in, I get 4 plus m minus 1, 7. Now technically, I don't actually need to simplify this because it doesn't specify to leave it in its simplest form, but just in case it does, I'm going to go through that. We have 4, then we're going to expand this bracket by multiplying this out. So we get 7n minus 7, so we get 7n minus 3 as our expression. With quadratics, you do something very similar. So the first thing you want to do is look at the difference. So it's going up by 6, then it's going up by 8, it's going up by 10, 12. Okay, so there's no common difference. So what I'm going to do is I'm going to take the difference of the common difference. So sorry, the difference of the difference. And if you notice, now there is a common difference between that. So with a quadratic, a standard quadratic looks like this, right? an squared plus bn plus c. Right? That's what a standard quadratic will look like. This number here is just twice as big as what a is. So a is just equal to 2 divided by 2, which is 1. So now I know my equation looks like this, n squared plus bn plus c. From here, I'm going to do simultaneous equations, but I promise you it's actually very, very short. So when n equals 1, right, the first term, yeah, I'm going to have 1 squared plus b, because n is 1, so b times 1 is 1, is b. It should equal 5, right? Which means b plus c is equal to 4, because all I've done is I've moved the 1 over to the other side. 1 squared is 1, minus 1 from both sides. And then when n equals 2, I get 2 squared plus 2b plus c should equal 11. So again, I'm going to move the 2 squared over to the other side. 2 squared is 4, so that would just be 7. So my two equations are this and this. I'm just going to subtract them, which gives me b minus 2b is minus b, c minus c is 0, 4 minus 7 is minus 3, so b is equal to 3. If I sub that into this equation up here, I get 3 plus c equals 4, so c is equal to 1. So my actual final answer A is 1, so we have n squared. B is 3, so plus 3n. And C is 1. That is my equation right there. It's very... I'm not going to lie to you. It is longer than... Well, the thing is, with guessing, this can be very tricky, right? This method is a bit involved, but keep in mind, you normally have 3 or 4 marks for this question, so you can spend 3 or 4 minutes. It didn't even take me 3 or 4 minutes, even while I was explaining it. Okay. You need to be able to change freely between related standard units, so time, length, area, volume, capacity, and mass, and compound units. So, for example, you may have to change from minutes to seconds, from days to hours. With the length, you need to be able to change between, you should know the fact that 1 meter is equal to 100 centimeters. And 1 centimeter is equal to 10 millimeters. Whoops. And from there, 1 kilometer is equal to 1,000 meters, right? With area and volume, this is where things get a bit more complicated. So with an area, what is 1 meter squared in terms of centimeters squared? A lot of students just write 100. That's not correct. It's actually 100 squared centimeters, okay? And the reason for this is when you have a square, right? What we're going to do is I'm going to work out the area of this square, which is 1 meter by 1 meter, okay? Then the area would be 1 times 1, which is 1 square meter, yeah? Now if I do the same thing on this other side, right, I'll have, but instead I'm going to make it into centimeters, right? So if I were to turn this into centimeters squared using this logic, right, using the logic that it's just equal to 100 centimeters squared, well, we'll see what happens. But if these two squares are the same size, so they should have the same area. I have 100 times 100, which is equal to 10,000, which is basically just 100 squared centimeters, right? If I just times this by 100, I don't get the same thing, right? Because what happens is, if you just times it by 100, you're only changing one of the lengths into centimeters, not both of them. And the same is true for volume. So for volume, it's 100 cubed centimeters, right? Because you have to change 3 different lengths into centimeters, okay? You need to be able to use scale factors, scale diagrams, and maps. So for example, if you have a model car that's a length of 8 centimeters and the scale is 1 to 50, you need to work out the length of the real thing. What this means here is that 1 centimeter is equal to 50 centimeters in real life. So all we're going to do is do 8 times 50, okay, which is going to be 400 centimeters. So the way you get that is if you're going from the smaller thing to the real life size, so from left to right, you always multiply. If you're going from real life down to the scale, you always divide by whatever the thing is on the right hand side. So it's nice and easy. First thing I would do is make sure the left number is 1. If it isn't, just divide by whatever that number is. And then I either times or divide by the right hand number, which is always the real life size. Express one quantity as a fraction of another, where the fraction is less than 1 or greater than 1. So here we have write Lily's age as a fraction of Hugo's age. So Lily's age, and it says in months, so I'm going to change this all to months. So 2 years is 24 months, plus another 4 months would give me 28 months. So 1 year is obviously 12, plus another 8 gives me 20 months. It says write Lily's age as a fraction of Hugo's age. So the first value always goes on top. So in this case 28. And then the bottom number is always the second thing, okay? So in this case, the first number we're talking about is Lily's age. The second number is Hugo's age, so it's Lily over Hugo. And then keep halving it. Okay. And if they wanted you to give it in a mixed number, which they would specify, you would just have 1 and 2 fifths. Use ratio notation, including reduction to its simplest form. So a password has 30 characters. It's made up of 5 numbers, 15 letters, and some symbols. We need to work out the ratio of numbers to letters to symbols. So I'm going to write N to L to S. At the moment is 5 to 15, and we don't know what symbols is. But it's only made up of numbers, letters, and symbols, right? So if I add these two numbers, I get 20, which means the rest of the characters must be symbols. So there's actually 10 symbols. So that's my ratio. Now to simplify ratios, it's a lot like simplifying fractions. I think, what can I divide all three of these numbers by? And the answer is 5. So my answer for n to L to S is 1 to 3 to 2 in its simplest form. You should be able to divide a given quantity into a ratio. So if Will and Ollie are showing £80, how much will each of them get? There's a few different ways to do this. One of them is like the bar model, where you kind of, assign squares to each of them. The way I prefer is, because it's another spec point anyway, so you may as well know it, is that Will is going to get a certain fraction of the money. Now what fraction is he going to get? Well, I can see that Will corresponds to the number 3. So I'm going to write the number 3. I'm going to divide it by the sum of all the parts of the ratio. So if there are 3 parts of the ratio, I'd add 3 numbers together. If there's only 2 parts, I add 2. So that's over 3 plus 2, which is 5. So all I'm doing is taking 3/5 of 80. 80 divided by 5 is 16, times by 3 would give me £48. From here, I can just do 80 minus 48 to work out how much Ollie gets, because obviously they don't get, they're sharing all of the money. But I'm going to use the same logic just to practice this for you. Ollie corresponds to the 2, so he's going to be 2, and the total is still 5 times 80. Again, a fifth of 80 is 16, times by 2 is £32. And to check your answer, if you add those two together, you do indeed get £80 again, which makes sense, because if you're sharing £80, it doesn't make sense for the sum of the sharing to be anything else. Express a multiplicative relationship, so that's when you that seemed a bit stupid. Okay, I'll explain that in a second, between two quantities as a ratio. So here it says there are only blue, red and yellow counters. There are twice as many blue counters as yellow counters, so this is what they mean by multiplicative, because I'm telling you there are 2 times as many blue as yellow. So in other words, blue is equal to 2 times yellow. So to write that as a ratio, all you would do is you'd put 2 to 1. Okay? Twice as many on the left hand side than the right hand side. That's how you do a multiplicative relationship. And then for red to yellow, you're going to do 3 to 1. Now it says write down the ratio of blue to red to yellow. So we need to combine these ratios. To do that, you need to make sure that there's a common letter between them. So in this case, yellow is common. And you need to make sure the number itself is common between them, which it is. So I can immediately just combine this nice and easy into one big old ratio. 2 to 3 to 1. Understand proportion and use proportion as equality of ratios. So if they're saying that 6 is equal to 10.74, you could write that as a ratio instead. And when you're going to 11, it should cost proportionally more money, right? In the sense that if I buy twice as many cakes, it should cost me twice as much money. And all that means is that the actual proportion stays the same. So in this case, I'd have to times by 11 over 6. How did I get that? Well, I just take this number and divide it by this number to work out what I times it by. So I'm going to do the same thing to the other side, times by 11 over 6. And that will give me the price of 11 cakes. So 10.74 multiplied by 11 over 6, which is 19.69. You should also be able to relate ratios to fractions. So as you can see from the previous part, that's why I prefer doing it that way. So red to blue is 3 to 5. So the fraction of the ones that are red is going to be 3 over 3 plus 5, which is 8. So that one. Nice and easy. Now it's all about percentages. So percentages being parts of 100. So essentially, percentages are just fractions out of 100. That's all that means. So to convert various different things into percentages, to convert a decimal into percentage is nice and easy. All you do is you times by 100. So in this case, it'd be 29%. To convert a fraction into percentage, you make the bottom number. There's 2 ways. You either turn it into a decimal, or you make the bottom number equal to 100. So in this case, it's equal to 50. So if I times it by 2, I should get 100. So I'm going to times top and bottom by 2. That gives me 6 over 100, which means I'm looking at 6%. The numerator is just the percentage. You need to take percentages of amounts. So 10% of 95, you just divide by 10 to take 10%. That's £9.50. The other way to do it, by the way, is if you remember back in the section where it says we need to interpret percentages and fractions as operators, you can do 10% on a calculator and times it by 95 in order to get, as well, 9.5. The next thing you should be able to do is work out percentage profit and loss. However, I want to point out that both of those are actually just percentage change. So yeah, with percentage profit and loss, they're actually the same thing. They're both percentage change. So I'm going to show you the percentage change formula because it means you don't have to remember two different formulas. So percentage change, right, is just equal to the new price, so either what they sold it for or whatever, minus the old over the old times 100. So in this first case for Emma, she's sold her house for 213,590 and it was originally 201,500 over 201,500 times 100. Okay, I know that's really messy and I do apologise. So if we just put it into our calculator, we have 213,590, 201,500 over 201,500, and then multiply that by 100. That should be 6%, right? Yep, 6%. Now, because it's a positive number, it means it's profit. So positive means profit, okay? Now with this one, look what's going to happen. The new price is 325,600, right? Because that's like the most recent price, if you'd like. Again, I'm still going to minus 352. Some of you may have already spotted what's going to happen right now. Hopefully, anyway. Otherwise, I've not explained this very well. So I'm going to do the exact same thing, okay? And you're going to notice that it should give me a negative number. So positive numbers for profit, negative numbers for loss, right? So we have 325,600 minus 352 over 352,123. Cool. Negative number as we anticipated, and it says minus 7.5%. So that negative tells me it's a loss. So if they're asking me specifically for the percentage loss, I don't actually need to write the negative. So if you're doing this, you just need to remember percentage change, okay? Because positive gives you a profit, negative gives you a loss, okay? Because the change in the value is negative, so it's a loss. You also need to be able to do reverse percentages and also compound interest. So reverse percentages, in a sale, the normal price of a book is 20% reduction. The sale price of the book is £4.80. So since it's reduced by 20%, it's currently at 80% of its current value, right? Does that make sense? Because again, 100% would be the normal value. So now you're just trying to get back to 100%. There are so many different ways of doing this. So for example, you could divide by 8 to make it 10%, then times by 10. You could use the kind of ratio thing that I mentioned before, where if you want to go from 80 to 100%, you're timesing by 100 over 80, and literally do that to both things. You can do to both sides, so times both sides by 100 over 80 for £4.80. You can also use, for example, the fact that 80% of x is equal to 4.8. So x is just equal to £4.80 divided by 80%. That will give you the same answer. You could do that as a decimal. There is like a billion different ways, right? So choose whichever one makes sense to you. 80, and then I'm going to use the percentage button. All of them should give you the answer of £6. Compound interest and depreciation and all that funky business. It may have been quite tricky for you to remember, but I'm going to show you using the percentage button on the calculator. It's a lot easier way to do it. Don't know why schools don't tend to do it, but whatever. Now, the key thing here is that interest and depreciation are opposites. Interest means you're going up in value. Depreciation means you're losing value, okay? So what they're basically saying is every year you're gaining 3%. So in other words, it's becoming 100 plus 3% of its value. So it's becoming 103% of its value. Yeah? Because if you're 100% your original, you're getting an additional 3%. So in total you're having 103%. So here's the formula. You take the original amount of money, 2,500, you times it by the percentage, so 103%, and you do it to the power of the number of years. That's it. Depreciation, you do the same thing, but instead of adding, you're going to be subtracting the percentage up here. So we have 2500 multiplied by 103. Please do not forget the percentage sign if you do it this way, otherwise you're going to get a massive number. And you get 2813, and you always round to 2 decimal places because money is a 2 decimal place thing. That's it. Solve problems using direct and inverse proportion, including graphical representations. Okay, so direct proportionality looks like this. It has to be a straight line that goes through the origin. It has to go through the origin. Otherwise, it's not directly proportional. Direct proportion means through the origin, straight line. Inverse proportion looks a bit funky. It's just the reciprocal graph. Like that. So how do I do this? Well, there's a few different ways. In some cases, you can just look at it and work it out. So I have some students that insist that they're able to do that. But then when it gets a bit more tricky, they're unable to do that, and then they don't know how to do it. And then it's confusing because they didn't practice on easy questions. So I'm going to show you the method that would get you all 3 marks, okay? First mark is if it's A is directly proportional to B, you write A equals KB. That's 1 mark, done. If it's inversely proportional, you do K over whatever it is. 1 mark straight away. You get another mark for working out what K is. So if you notice, they give me 2 values. A is 7, B is 28. So 7 equals 28B. 28K, I mean. Divide both sides by 28, we get K is equal to 7 over 28, which is a quarter. Second mark done. So my equation is now A is equal to a quarter of B. The last mark is to find what B is when A is equal to 5. So sub in A is equal to 5, A is equal to a quarter B, times both sides by 4, B is equal to 20, third mark. Just writing this first line gives you a mark. Then working out K is just solving a linear equation, 2 marks. Then subbing in the last value, 3 marks. So you're literally reading this like a book. I've used this first piece of information for the first mark. I use the second piece of information for the second mark. Third piece for the third. So a lot of students tend to like jump about, and a lot of students actually just read this last bit, right, of any question. They read this last bit and they go, yeah, I don't know how to do that, or, oh, I'm going to jump straight there. If you read it in order, you can get marks for each of these pieces of information. Same thing here. So we've used the first sentence to get the first mark. Now we're going to use the second sentence. C is 3, D is 8. So we have 3 is equal to K over 8, times both sides by 8, K is equal to 24. Second piece of information used. Cool. Easy, right? Then use the last piece of information. So first though, I want to write out that C is equal to 24 over D. It says find the value of C when D is equal to 2. So C is equal to 24 over 2, which is 12. Third mark, third point. It's that easy. Can you do it all on a calculator? Absolutely. I'm not going to lie to you. You absolutely can. But if you make a mistake, you've lost 3 marks. Is it worth it? I don't know. Again, the whole point of an exam is not just to get the answer right, which might sound stupid, but it's actually to show the examiner you know how to do maths. The only way to show someone you know how to do maths is to use a method. This is something I've only learned recently, really. So I also used to just kind of skip to the answer and stuff. But then if I got an answer wrong by a single decimal place, or I didn't round it properly, I lost 4 or 5 marks for the whole question. So I remember one time, the answer was 24.5, but I left it as 24.49. I actually rounded it to 2 decimal places. So I lost 5 marks for that question because I didn't use any method. Whereas if I did a method, I could have got 4 out of 5. But instead I did the whole thing on a calculator. So just keep that in mind, learn from my mistakes. You need to use compound units, so speed, density and pressure. So speed is just equal to distance over time. So 200 over 25, and you should be able to then work out what the units are. So that would be 8. Yeah. So what are the units? Well, the distance was in meters, so I'm going to write meters. And the time was in seconds, so I'm just going to put /seconds. That's how easy it is. If you're dividing, you literally just put whatever this unit is, divide this unit. That's it. So if this was meters, it could have been per hour, it could have been kilometers per day, it could have been whatever. And I'll just put km/d, whatever. Density is just mass over volume. So 760 over 40. So cancel out the zeros. Half of 76 is 38. Half it again gives me 19. And what are my units? Well, it says grams. And so I divided this number by this number. So it's grams slash that number. That's it. Pressure is the last one, and it actually gives you the formula for this normally, which is force over area. So 120 over 2. Again, if you ever want to divide that kind of big numbers, ignore the zeros on the end. Do 12 divided by 2, which is 6, then add the 0 back. And again, this would be newtons per square meter. Because again, we did newtons divided by meters. Easy as. Oh boy, now we get to do scale factors, which is everyone's least favourite thing, I wholeheartedly believe. So let's have a look-see. With a scale factor, we're talking about similar shapes. They're similar because all of their lengths have been times by the same value. So in this case, 8 has been times by something to give me 12, 26 times by something to give me whatever this would be, and so on. So calculating the length PR, which is this length here, involves me timesing 26 by something. But I don't know what that something is. What you do is you find the pair of sides that are actually matched, and you work out the scale factor. How do you work out the scale factor? You divide the big number by the small number. You just divide whatever's on this side divided by this side. And again, it has to be the corresponding side, which you should find equals 1.5. So all I'm going to do is do 26 times 1.5, which is 39 centimetres. Now what if I need to go to BC? So if you notice I'm going from 45 to this. Well, I can see my number's going to get smaller, right? Because it's gone from the bigger shape to the smaller shape. So instead of timesing by 1.5, I just divide by 1.5, which should give me an answer of 30 centimetres. So what if you have to work out surface areas and volumes? Well, I'm going to show you exactly how that works as well. And we've done some grade 9 questions on this in the, I think it was the paper 2 live stream, so aiming for grade 9 paper 2. Let's start with the radius, right? So the scale factor between these two things is times by 2. So the length scale factor is 2, right? You could also write this as 1 to 2 if you want, but it doesn't really make much of a difference. If it's the area, you square it, and if it's the volume, you'd cube it, okay? So the scale factor of the areas is 4. So to go from A to B, I'm timesing by 4 for the area. So 80 times 4 is equal to 320. And I mentioned that in order for the volume, you work out the length scale factor and you're just cubing it instead. So it equals 8. Now the volume of shape 8 is 600 and we're going to A. So instead of timesing by 8, we're going to be dividing by 8. Let's just use a calculator for this. Just realised you can't see that. There we are. 75, alright. Easy as pie. You also need to be able to construct and interpret equations. We've already kind of done that already, so we don't need to really go through that. Interpret the gradient of a straight line as a rate of change and show that it illustrates like direct or inverse proportion. So I've already shown you the direct proportion. It's a straight line through the origin. Believe me, that is meant to be through the origin anyway. So this graph is not direct proportion because it doesn't go through the origin. It crosses at 20,000, so it's not direct. And again, inverse was the kind of inverse shape. So when it's asking you for a rate, you're always going to be working out the gradient. And the reason why they're saying rate is because our x-axis is time. So all we need to do is find 2 points that are reasonably decent. So and literally just do the big triangle thing again, okay? So let's have a look. It goes from 80,000 to 100,000 in 10 blocks. So it goes up in 2,000. So 82, 84, 86, 88, 90, 92, 94. So that goes up to 94. Actually, a hot tip, by the way, is you don't actually even need to write the thousands, because 94 over 20 is actually the same as doing the other way, but either way it's fine. So the difference here is 74,000. And the width is 20. So all we're doing is doing 74,000 over 20, which is of course 3,700 litres per hour. Easy, hopefully. If you're a higher tier, you have to interpret the gradient of a curve as an instantaneous rate of change. Okay, so in this case, it's asking us to work out the gradient, and it's at 6 seconds. I'm not sure why I didn't copy over. So what you'd have to do is draw a tangent and just work out the gradient of the tangent itself. Keep in mind that I haven't done this using a ruler, so it's not going to be super accurate. But then you're just doing the gradient thing again. Okay, so we have growth and decay. So this is actually pretty much the exact same as just compound interest. So we've already done a couple of these before, but let's go through it. So with this, we're going to do the exact same thing as before. 100% plus 1.8, so 101.8% is our interest rate. So we have 9, well, it's not our interest rate, but it's our percentage increase. Again, don't forget the percentage sign, very important, and 5 years. That's literally all you're doing. Nice and easy. Now, the opposite of interest, I did mention before, is depreciation. Okay, so with depreciation, it means that your thing is actually decreasing value over time. But there's actually there's another reason why I chose this question, because the depreciation rate, or the percentage, changes. Okay, so that makes it a bit more interesting. So again, we start with our original amount of money, and we times it by, so if it decreases by 30%, that's 100 minus 30, which is 70%. Okay? And we do it to the power of the number of years, so 1. Then you can just chain on the new rate. Like, it's that easy. Then it decreases by 14%. Don't do 70 minus 14, you're still doing 100 minus 14, okay? The maths just works out really nicely with regards to that. And how many years? Well, second and third year, so 2 years. That's all you do. You can chain on different interest rates, but I know it's something that sometimes you don't get shown in schools, which is a bit of a shame, but it is actually quite, it's not the worst thing in the world. Okay, I tried doing shift 5 for percentage, but it didn't work. Okay, and then 86%, shift that, bish bash bosh, 2, and we get the correct answer here, 9,318.96. And again, remember 2 decimal places. This is already in 2 decimal places, so it's nice and easy. And again, this spec point talks about iteration again. We've already done that, nice and easy. And that brings us to the end of the ratio, percentage, etc. section. Now on geometry, we only have 2 more after this, and they're actually quite short. This is another medium length one. We've done all the longest ones, so we're almost there. Look at all of that. Okay, so basically you need to know a bunch of different terms. So points just refers to a certain position. Lines refers to kind of it's the same thing as an edge, almost. So a line is just a straight kind of line, right? A vertex is a corner. That's what we call corners now, okay? An edge is a side of a shape, 2D or 3D. A plane is just a 2-dimensional shape, essentially. Parallel lines are 2 lines that will never meet. Perpendicular lines meet at 90 degrees. Right angles are 90 degrees. Polygons is just a many-sided shape, so anything above 2. So triangles, squares, pentagons, hexagons, etc. all polygons. A regular polygon, so if you see the word regular, so regular octagon, regular pentagon or something, it means all of the sides are the same length and all of the angles are the same size. And polygons which have different symmetries, which again, if they're regular, they tend to have at least 1 degree of symmetry for reflection and even rotation as well. You need to also be able to label and refer to sides. What they mean by that is saying, okay, which one's the width, which one's the height, which one's the depth kind of thing, okay? And angles of triangles, and draw diagrams from written descriptions. So draw shapes. Cool. So let's get on to this one. So you need to be able to do this topic, which is basically just construction, okay? So you need to be able to construct from information given to you. You need to use a ruler and a compass to do that. So I'm going to show you this one, but honestly there are great videos on YouTube showing you how to do every type of construction that you can possibly need. So this would be a bit more brief than that. So if they ask you to draw this triangle in real life, like on a piece of paper more accurately, I would start by drawing a flat line of 10 centimeters to make this side AB. To draw the length 6 centimeters and 8 centimeters, what you don't do is draw a line of 6 centimeters and then try and join a line of 8 centimeters, okay? Instead, what you're going to do is you're going to put your compass on this corner here, A. You put your compass so that it's 6 centimeters long. So you open it to 6 centimeters and you draw an arc from A of 6 centimeters, right? So a big arc. You then put your compass onto B and open it to 8 centimeters and do the same thing. Those two arcs will cross, 100% guaranteed, okay? Where they cross is where your point C is, so you just draw a line going from A to C and C to B. With this question here, so the stadium is going to be built, it must be no more than 10 kilometers from town A and 8 kilometers from town B. 1 centimeter represents 2 kilometers, so straight away we can say that this would be 5 centimeters on our diagram and 4 centimeters on our diagram, respectively. Shade the region. So what you're going to do is you're going to... So, actually, before I go on, if you're trying to look for something that's no more than 10 kilometers from a point, so no more or no closer than a certain distance from a point, that's a circle, right? So if I'm standing up, right, if you remember like the COVID days and they said you have to say 1.5 meters from someone, right? That's like saying you must be no closer than 1.5 meters from someone. That's in a circle around you, right? Same thing with these points. So what you're going to do is set your compass to 5 centimeters, put a point on B, and draw a circle. Full 360 degrees. Same thing on A, but you move it to 4 centimeters, your compass. Do the same thing. They will overlap somewhere in the middle. You shade that overlap. Easy as pie. You then apply the properties of angles at a point, straight line, blah, blah, blah. So you need to do angles on parallel lines and also... So I'm going to draw all these out for you right now. The first one is vertical angles are equal. The reason why I'm writing them out like this is because you must reference these as your answers. In every one of these questions, bar none, they will ask you for a reason. If you cannot write the mathematical reason, you get 0, even if your answer is correct. So vertical angles equal. If you make an X shape with 2 straight lines, so you've got straight line, the opposite angles here and here, and also here and here, are equal to each other. Okay? So both of these are, let's say, A, and both of these are B. So if they ever say, like, okay, this is 34 degrees, what's angle B over here? You'd say 34 degrees, vertical angles equal, done. Next one we're going to do is these 2 lines here, and this is true for all of these questions, by the way. They're parallel. You have to have 2 parallel lines, okay? You have to use any of these, except for the first one, of course, is what you may have heard be called Z angles. So these 2 angles are exactly the same, and also backwards Z, right? Actually, no, this way is actually the correct Z, that other way is not. Anyways, this is called alternate angles are equal. Okay, and essentially, if you can make a Z shape, and also I should say that for most of these, you can actually use all 3 of them, but you have to make sure you're using the right reason, okay? So you can use any of them. But if you look, these 2 opposite angles here are equal, and these 2 are equal, and you'd say alternate angles are equal. This, can you see, looks kind of like an F shape, right? Kinda. Well, this angle here is going to be equal to this angle here, and again, the reverse is true over here. Okay, and for that you would say corresponding angles. Equal. I'd recommend just practicing with these in order to kind of understand it a bit better. For this one, it's a C shape, right? Kind of like a C. I actually prefer to say like a U shape, but whatever. Like a horseshoe, like a C shape, whatever you want to call it. Now, here's the key thing about this, right? If you notice, I'm actually labeling all of these with different letters because they're not the same. Co-interior angles, that's what this is called, add to 180 degrees. And you actually get to this by using a combination of the previous 2, which is fun. So in other words, C plus D equals 180. And I'm a genius. A plus B is equal to 180. Okay, so the insides of that shape. So a lot of the times corresponding and co-interior get confused, understandably so, but just try and practice. So have these printed out in front of you or written out in front of you, whatever. Whenever you're doing questions, you can refer to it. Remember, you only need to remember them for the exam. So while you're practicing, you can have them in front of you, and over time you'll learn them. These last two equations, they don't necessarily fit into a spec point, kinda, although you're expected to know them. So I thought I'd put them here because we're talking about angles. So the sum of all the interior angles of an n-sided shape is just n minus 2 times 180. Super useful formula. Some people try and memorize what the angles add up to in a 5-sided shape, a 7-sided shape, an 8-sided shape. That is a waste of time. Use this. If it's a 5-sided shape, n is just 5. 3-sided shape, n is just 3. 4-sided shape, and so on. So if we did it for a triangle, 3 minus 2 is 1 times 180 is 180 degrees, just like a triangle. 4-sided shape, and so on. And the exterior angles is just, so each exterior angle is just 360 over however many sides you have. You need to know what the properties and definitions of special types of quadrilaterals are. So here we go. It should actually be noted that a rectangle is a special type of parallelogram and a square is a special type of rectangle. So, and I'll go through why in a second. So with a square, all sides equal and all angles equal. Fascinating, right? So again, that's a square with a, actually let me write out the names. With a rectangle, and this is the key part here, only the opposite sides are equal. Okay, and they're parallel to each other, hence why it's a special type of parallelogram. And again, all of the angles are 90 degrees. Those hopefully aren't really too spectacular. Now this shape over here is a parallelogram. So you literally write the word parallel, and you put ogram at the end. And the key part here again is that the opposite sides are parallel and therefore the same length. But something more interesting is that angles that are next to each other, so again if I label these A, B, C and D, angles that are like interior to each other, because this is just a co-interior shape, right, add up to 180 degrees. So all of the ones that are adjacent to each other add up to 180 degrees. And so on. And what's even more interesting, and I use the word interesting very lightly, is that opposite angles are actually equal to each other. Like that. I made a mistake. A equals D and B equals C is what I should have written. My apologies. So opposite angles are completely equal to each other and the adjacent angles add up to 180. So that's fun. I don't know why I said it like that, but yeah. The next one is a trapezium. So again, opposite sides are parallel to each other and that's it. So they only have two parallel sides. Okay? And with this one, there's not that much interesting about it. It's just that, again, the co-interior thing. So A plus B equals 180. And you can do it for the opposite side as well. But the opposite angles are not equal. God damn it. Right. So a few differences between a trapezium and a parallelogram. Obviously only one pair of sides is parallel. But A plus B is 180. C plus D is 180. But A plus C and B plus D do not add up to 180. And the opposite angles are not equal. Okay? So only kind of the vertical sides add up to 180, I guess you could say. This is just a kite. The key thing here is that it's completely symmetrical down the middle, which means these sides are equal and these sides are equal in length. They're obviously not parallel, but it also means that these angles are equal to each other as well. And lastly, we have a what's called a rhombus, where all of these sides are actually the same length as each other. The only thing is that they've been slanted. So I like to think of it as it's a square that's been pushed over to the side slightly. And yeah, congruence criteria. Cool. So congruence just means that they are completely identical. Now, of course, they could have been rotated around and stuff, or moved about, but all of the sides and angles are exactly the same. Okay. Again, I've got a lesson on this on the channel, so feel free to have a look at that if you're a bit unsure. Again, this is just meant to be like a very brief overview. The S stands for side, so you can either have 3 sides the same, or you can have 2 sides and the angle between them the same, or you can have 2 angles and the side between them, or you can have that it's a right angle triangle and the same hypotenuse and side. So again, if I do this as an example, they're asking me to prove that ACB and CDB are the same triangle. Well, they share this side, so they share BC, so that's obviously the same. Opposite sides of a parallelogram are the same length. So basically, due to SSS, all 3 sides are the same, so they must be congruent. However, you can also use the fact that the angles are the same, the opposite angles are the same, so you can use SAS as well. You can actually use all 3. You can't use the right angle one though, because it's not a right angle triangle. So again, you just need to do simple proofs based on that. So what we did just now is a simple proof, proving that they're congruent. You also need to be able to do scale factors, and if you're in high, you need to do negative scale factors, so let's do it. So the first thing you do with any scale factor is you put the center of enlargement. So 1, 0 is right here, and all you're doing is you're working out how far to the right and up or left and down you're going to get to each point. So if I look at this first point over here, I go to the right once and I go 2 up, right? So right once, up 2. Now because it's a scale factor of 2, I'm going to times both of those by 2. So I'm going to go right to the right twice, and I'm going to up 4. So I go 1, 2, 1, 2, 3, 4. So now that point there that I've highlighted is actually up here. Now from here you could actually just draw the rest of the shape. So for those of you who are actually pretty good at this, you can just draw a shape that's twice as big, so go 4 up and then across. But I'm going to do it fully just for those of you that are a bit less sure. The next one, I go 1, 2, 3, 4 to the right. So right 4. So that's now going to become right 8, because I times it by 2. And I go up 1, 2, twice. So again, up twice. And this should hopefully make sense, because I should be on the same level as this point, right? Because the shape doesn't rotate or anything. It just gets bigger. So we go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Cool. And for the last point, up here, we go right 1, and we go up 1, 2, 3, 4. 8. Cool. So 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. And then all you're going to do is draw with straight line, hopefully. Again, use a ruler. Don't be a naughty boy like me. Draw the triangle. With a negative scale factor, you're going to do the same. However, it's going to change the direction. Okay? So again, let's put our center is 0, 1, so here. And again, let's do each point. So I go 2 to the right. I go 1 up. So now I'm going to times it by 2, as usual. However, because it's negative, I actually change direction as well. Okay, so I don't just kind of times it by 2. I'm also going to go in the opposite direction. So instead of right, I'm going to go left. Instead of up, I'm going to go down. Okay, so 4 to the left makes me go 1, 2, 3, 4, and then 1, 2. So right here. Okay, now this one is actually going to rotate, which is interesting, I suppose. It is to me anyway. And then we're going to pick this point here. How far to the right we go? We go 4 to the right, and we go 1 up. So we're going to go 8 to the left, right? Times it by 2, and then opposite direction. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Now you can probably guess that since this point here is in the middle of the 2, you're just going to put it in the middle and somewhere down here. But, you know, let's not guess. We don't need to guess. We're big brains. We're going to go 3 to the right. And 1, 2, 3, 4 up. Right? So again, 1, 2, 3, and then 1, 2, 3, 4. So we're going 6 to the left, 8 down. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Right there, and again, you should notice that it actually flips upside down. That is intended, because when you do a negative scale factor, it's actually a reflection, which is, well, it's also a reflection, I should say. Now, sometimes invariance just means, always it means, that it doesn't change overall. So you need to be able to identify when things are going to be invariant. So all you do is you follow the transformations they give you and show that it ends up in the same place. Bunch of circle stuff. Lovely jubbly. Alright. First thing we're going to start with is a chord. A chord is just a line that goes through a circle. Okay? So it goes from one point on the circumference to another point, and it can be anywhere. Right? So that's also a chord. That's a chord. That's a chord. That's a chord. Everywhere. Now, a diameter is a special type of chord. So there has been a question before where it says a diameter is also the answer is chord. Okay? Because it is a chord that goes through the center of a circle. Now, the radius is just half the diameter, so it goes from the center to the circumference. Circumference is just a fancy word for the perimeter of a circle. And this here is a tangent. And a tangent is a line that only touches the circle once. So it doesn't go through the circle, it just touches it once. Okay? A sector is basically a pizza slice like this, right? And a segment is what I've got in orange. It's when you put a chord through a sector. If you are in higher, you get the privilege of doing circle theorems, which is really fun. So here's all the circle theorems you need to be able to do, and I've shown a few example questions here. So for example, in the first one, a tangent meets the radius at 90 degrees. So all you're doing is working out what that last angle is. So 180 minus 90 minus 72, which is 90 minus 72, which is 18 degrees. And here we're using the fact that angles at the center are twice at the circumference, so you just half it, it's 33 degrees. Now you might notice it says, give the reason. Generally speaking, all circle theorem questions you have to give a valid reason. You also have things like this for your... So what that basically involves is sometimes you do coordinates and shapes together. So writing down the different coordinates, so this one will be 1 minus 2. Midpoint of AB, you can just do this by kind of looking, essentially. So it'll be right there. And then it says ABCD is a square, so on the grid mark the point so that it's a square. Well, a square has all equal sides, right? So if you notice, all of these go one. There's one difference vertically, and there's 1, 2, 3, 4 horizontally. So again, 1 and 4. So all we need to do is go 4 to the left. 1, 2, 3, 4. Wait, 1, 2, 3, 4, and then 1 up in order to work out. And if you look, that does look exactly like a square. You also need to identify properties of the faces, surfaces, edges, and vertices of cubes, cuboids, and prisms. You also need to be able to identify properties of the faces, surfaces, edges of various different shapes, so cubes, prisms, and cylinders, etc. So with a prism, so whether it's a cuboid or it's a triangular prism or it's a cylinder, all you need to know is that the opposite faces are the same, and then you have kind of 4 identical faces here. So you just need to be able to look at a shape and determine how many different faces it has. So in this case, with a cuboid, you have 4 identical faces on the front, the top, the back, and the bottom. And then you have these 2 side faces, but with this triangular prism, you have 2 same here. Then this back side and this bottom side is also different. You also need to be able to interpret and construct plans and elevations of 3D shapes. So a plan is a top-down view. So what it's saying is it should be 3 wide in total, 3 long. And there's also this dark line here which shows that it has 2 levels to it. Okay, the front elevation is the front view from the front. Side elevation is the view from the side. I know that's very specific, but here's what the shape would look like to translate this. If you aren't too sure about getting this, then do let me know. So you're going to have, I would just draw the front elevation as usual, and then we just want to turn it into a 3D object by doing something like this. Right, and again, you don't have to be like an artist or anything. And then in terms of the actual dimensions, because it says label them, this side here is 3, the height here is 2, because that's what it says here. The width here is 2, so each of these steps is 1, and that's all you'd have to label. We've done the kind of units of measure and related concepts, so length, area, and volume at the beginning of this topic, so go back to that section if you need me to go through it, like what units you need to use. You also need to be able to measure line segments and angles, so basically you need to be able to use rulers and protractors accurately and properly. You need to be able to calculate the areas of a bunch of shapes. So, with a triangle, you do a half the bottom side, base, times the height. So in this case, it's half b times a. If you're a higher student, bear in mind that there is another formula that you'll have to do, which is the half ab sine c, but we're not doing that just yet. With a parallelogram and a trapezium, when we talk about the height, you have to use the perpendicular height, the absolute vertical height, not the slanted lengths. So in this case, it would be a half the base, so I'd call it a times the height. And here is where it gets a bit more interesting. You do a half, you add the two parallel sides together, and then you times by the height. With any kind of prism, the way you work out the volume is you do the area of one of the faces. So in this case, you would take the area of maybe this, and you times it by its height, sometimes called the length. So here you could work out the area of the front face and times by the length. Here you'd use pi r squared to work out the area of the circle on top times by the length. You have a bunch of these different formulas, so you need to know the circumference and the area of a circle. You need to be able to calculate perimeters of 2D shapes and areas by breaking them up into composite shapes. So as you can see here, you can break this shape into a triangle and a rectangle. So 5 times 7 times 4 times 5 over 2 will give you that answer. And the same thing for this one, you can break it into multiple shapes. In this case, it'd be a trapezium and a rectangle. You need to be able to calculate arc lengths, angles, and areas of sectors. So in terms of area, a sector is just a fraction of a circle. So all we're going to do is take a fraction of the area of a circle, so pi r squared. But how do we work out what fraction we take? Well, you look at the angle. Now, angles in a circle should add up to 360. So all you do is you take the angle they give you and divide it by 360. And that is what you times that by in order to get whatever the area is. So in this case, 150 over 360 times pi times 8 squared. You do the same thing with the arc length. So an arc length is just a fraction of the circumference. So the circumference is 2 pi r. So you just take a fraction. So 125 over 360. Nice and easy. You should also apply concepts of congruence and similarity to find areas and volumes, which is exactly what we did earlier when we did scale factors. That should all be fine, but again we may have some extra ones. So know the formulae for Pythagoras' theorem and all the trig stuff and use them to find angles and lengths. And here it says apply them to find angles and lengths in right angle triangles where possible, general two triangles in 2 and 3 dimensional. So that sounds very complicated. Basically, for right angle triangles, that's foundation tier. In higher tier, they might introduce a 3-dimensional aspect to it. Okay? And by that I mean they might have like a 3D shape and then work out an angle, and it's just a bit difficult to visualize. Other than that, it should be completely fine. So for this, so when do you use Pythagoras versus trigonometry? Well, both of them, it has to be right angle. It has to be. Now, you only use trig if you want to find an angle or you're given an angle, right? So in this case, if you look at the first one, I have two sides. I don't have an angle and I want a length. So I don't have an angle and I don't want an angle, so it's Pythagoras. And again, you just label this as C, because with Pythagoras, the only letter that matters is what C is. The rest of them, it doesn't matter which way round you do it, because you're just squaring and adding them. So you have 4.8 squared plus 3.6 squared, C squared. So type that in on a calculator. It's 36. Well, that's a nice number. So don't forget, that's not what C is. C is the square root of 36, which hopefully you know is 6 centimeters. The next one, work out the value of x. Well, I have a side and I want a side, so it's Pythagoras, right? No, because we get given an angle. So here's how you do trigonometry. Again, I'm not going into super detail about this. This is just like a quick recap. The opposite side to the right angle is always h, it's hypotenuse. The opposite side to the angle you're given, or the one that you want, is always opposite, and the one that's next to the angle, the other one that's left, is just the adjacent. So I'm going to write out toa. Yeah. Now I want side h and I have side o, so I have o and h, which means I'm going to be using so. And so just says that sine of the angle, so sine 35 is equal to the opposite side 20 over the hypotenuse, which is x. So if I rearrange this, so times both sides by x, then divide both sides by sine 35, I get x is equal to 20 over sine 35. So all I need to do now is enter in a calculator. Okay, which is 34.9, let's call it. Okay. And for the next part, we need to know the exact values for sine, cos, and even some for tan as well. So how on earth do we do this? Well, it's actually not that bad. There is a little trick that you may have already seen, but I always do it in like a little table. So we do sine, theta, and then write down the values on top. So 0 degrees, we need 30 degrees, 45, 60 and 90. Now here are the values that you need. You need to do, it's 0, half, root 2 over 2 or 1 over root 2, depending on which way around you look at it. Root 2 over 2, and then the next one is root 3 over 2, and the last one is 1. Now how do I get those? Well, all you're doing is actually adding 1 each time. What do I mean? Well, here's what you do. You put over 2 for all of them. Okay? So all of those over 2. And then I start at 0, square root 0, square root 1, square root 2, square root 3, square root 4. Square root of 0 is just equal to 0, so we've got 0 divided by 2, which is 0. Square root 1 over 2, well, what's the square root of 1? It's 1, so 1 over 2. Square root 2 over 2 is just square root 2 over 2. Square root 3 over 2 is just square root 3 over 2. And square root 4 is 2, so 2 over 2 is 1. So effectively, all you're going to do is put a over 2 for all 5, and then square root and go up in ones. So square root 0, square root 1, 2, 3, 4. Okay? Now cosine is also pretty nice. If you want, you can do the same method, but you're doing it backwards. It's a count down. Okay? So you're going to be doing square root 4 over 2. You literally do the exact opposite. And can you see I'm just counting down? So in the first one, I'm counting up by ones. In the other one, I'm just going down. Or if you've already written out the other ones, you can just literally copy it from here, right? And 1 over 2, because it's just square root 1, and then that would be 0. Cool. I will say that as you use these more and more, I would recommend having them written down in front of you on a little post-it note or something. And then when you're doing any trig questions, just instead of using a calculator, try and, if you know that it's 0, 30, 45, 60 or 90, just try and refer to that sheet instead. Now tan is a little bit of a more difficult one. Now you might notice that I might actually give you more than what you need. Here's the hint. Tan is equal to sine over cos. So all I'm going to do is I'm going to divide these two things. So 0 divided by 1 gives me 0. A half divided by root 3 over 2, it just flips the fractions, right? You change that to a times. equals 1 over root 3. Okay. Does this take a bit of time? Absolutely, but it's kind of guaranteed. Root 2 over 2 divided by root 2 over 2 is 1, right? Root 3 over 2 divided by a half will just give me root 3. Again, for the same reasons. Root 3 over 2. We keep change flip, so that would be times 2 over 1. So then that would just become 3. 1 divided by 0 is just undefined, okay? So you didn't actually need the 91. So I will say that a lot of them, so this one and this one are pretty easy. And then you can kind of remember it as it's 1 over root 3 and then it flips to root 3, however you want to remember it. But these first two, if you can use this trick to remember them, it means you'll always be able to work out the tan version. Because keep in mind, you'll only ever really be asked one of these, like, how many are there? 15 values, right? They'll only say, use the fact that sine 30 equals something, right? Or they'll give you a trig question and it'll say cos 60 equals x, what's x, or something like that. So they'll only ask for one of these values, so there's a much bigger chance of you being asked sine or cos. But again, that means if they do give you tan 30, you can work out sine 30 and cos 30 and divide it to get what tan 30 is, okay? So it is possible, you don't need to memorize it, except this trick. Higher tier, you need to be able to use the sine and cosine rule to find unknown lengths. So with the sine rule, it's very difficult to know when to use sine versus cos rule. Generally speaking, cos rule is if you have two sides and an angle between them, or you have three sides and you want an angle. It's a bit more tricky. However, with practice, you'll know when to use them. So this one, immediately I'm thinking sine rule. Why? Because I have an angle and its opposite side, and I have an angle and I want its opposite side. So in this case, it's literally just going to be, and if you want the opposite side, I would recommend doing the side on top. But keep in mind, if you want an angle, you can actually flip the sine rule over. So there's no harm if you're working out an angle just doing sine A over A equals sine B over B. So that's one of the powerful things with the sine rule. It's equally easy if you want an angle or a side. The rearranging is actually identical. It's just that you need to change which equation you use. And that would just be 13 sine 38 sine 100. Okay, and you'll enter that on your calculator. Again, remember to always use brackets and things like that. So we have 13 sine 38. It actually opens brackets for you, so that's nice. Over sine 8.13 centimeters. Well, it actually says to one decimal place, so 8.1 centimeters. And with the cosine rule, if you look, I have two sides and the angle between them. And what the cosine rule basically says is the opposite side squared to the angle is always equal to the sum of the other two sides squared minus 2 times the sides multiplied together cos the angle between them. Okay, so again, what I would do, and this is my personal preference, is whatever angle I have or want to work out, I call it A. Right? And the reason for this is that there are some schools and some things on the internet that will say you have to memorize 3 different cosine rules. One if you want to work out A, one if you want to work out B, one if you want to work out C. You don't. That's a load of nonsense, right? All I would do is whatever angle I have or want, I label that A, and the rest of the labeling doesn't matter, right? All you need to is make sure the side opposite is also lowercase a. The other two sides don't matter. Because think about it, all I'm doing is adding them or timesing them. You can add and times in any order you want. And then here is the formula for the area of a generic triangle, half AB sine C. Okay, so again, if you don't have a right angle triangle, you actually do need to use this formula. So the area in this case is just a half. So where does the AB sine C come from? Well, A and B are just two sides and C has to be the angle between them, okay? So as long as you have an angle and sides next to the angle, you're completely and utterly fine. Okay, so again, doesn't really matter what you call the letters, you just need two sides and the angle between those two sides. You also need to be able to describe translations as 2D vectors. So vectors aren't just those scary things at the end of like paper 3 or paper 2. They are actually used for translations. The top number tells me how far right or left I go. The bottom number tells me how far up and down I go. Positive numbers means right and up. Negative numbers means left and down. So we're going 3 to the right, not left, and we're going 2 down, not up. So all I do is I take each point and I just go 1, 2, 3, 1, 2. Right? Take the next point. 1, 2, 3, 1, 2. And once I know exactly, I know that this last point is going to be 3 points up, right? And then I'll just join all the points together. I'll do it just for the sake of completion. Like that. Perfect replica right there. You also need to be able to add and subtract vectors and also multiply them by scalars. And for higher tier, you need to also do proofs, which is fun. So write these as a column vector a plus b. When you add vectors, it's actually quite pleasant. All you do is you add the top and bottom numbers. It's not like fractions where you have to make the bottom number the same. All you need to do is add the numbers. So 2 plus 1 is 3. 3 plus 5 is 8. Now what about multiplying them? So when you have 2 times a plus 3b. Well, again, it's actually quite pleasant. All you need to do when you multiply by a scalar is you times both numbers by the number outside the bracket. So it's 2 times 2, which is 4, 2 times 3, which is 6, plus 3 times 1, which is 3, over 5 times 3, which is 15, and then again we're adding the numbers. Easy. It says here points, this vector C is drawn here. So as I can see, the vector is just 2 to the right and 1 up, so that's 2 and 1. And it says draw the vector 4C. So if I wanted to work out what 4C would be, it's going to be, equals 4 times 2, which is 8, 4 times 1, which is 4. So I need to draw something that goes 8 to the right and 4 up. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So there, and then it would be a straight line joining them. That's it. The only other thing, by the way, is I've underlined it because C is a vector, so we tend to underline vectors. If you notice, they actually write them in bold, but I can't write in bold, and neither can you. So unless you're typing it, which would, possibly, I would recommend underlining it. Probability, probably one of the scary topics. All you have to do, I'll go through this quite slowly, but the first one, there aren't many points, by the way, in this. It's just that probability really sucks. Record, describe, and analyze the frequency of outcomes using tables and frequency trees. This here is a frequency tree. So it says 30 people took a literacy test and a numeracy test, and 23 people passed the literacy test. Okay? So, in total, if you look here, how many people took it? Well, 30 people took a literacy and numeracy test. And then it says, how many people passed? Well, 23 people passed. Which means 7 people must have failed, right? So think about it. The good thing about frequency trees is if you look along these, this 30 is being split up into 23 and 7. So what that means is that these two numbers have to add up to 30. So if I use this logic in the top branch of the tree, this 23 is being split up into 21 people who passed and some number of people that failed. Well, think about it. This must be 2 then, because these numbers should add up to 23. Likewise here, 7 people failed and they're split up into 3 people who failed the numeracy test. And how many people passed? Well, it must be 4, because this 7's being split up into those 2 numbers. Okay, it needs to still add up to 7. Apply ideas of randomness, fairness, equally likely events to calculate expected outcomes of multiple future experiments. So calculating expected outcomes, something like this, right? All you need to do is you take the probability an event will happen and you times it by the number of times that they're doing the experiments. In this case, they're rolling the dice. So times it by 200. So 0.3 times by 100 is 30, times 2 should be 60. So it should land on 6 60 times. That is the expected outcome. It doesn't mean that this will guaranteed happen, right? Like I could flip a coin. If I flipped a coin 4 times, you would expect me to get 2 heads and 2 tails. But it's possible for me to get 3 heads and 1 tail, or no heads and 4 tails. So again, this is expected, it's not guaranteed. Okay? So randomness and fairness, well, when something's random, it means that the probability, you can't determine it, right? Fairness means that all outcomes are equally likely. So when I flip a coin, it's equally likely I get heads and tails, hence it's fair. When I roll a normal dice, an unbiased dice, it's equally likely for me to get a 1, 2, 3, 4, 5, and 6. So again, whenever they say work out an estimate, and they've given you a probability, all you're doing is taking the probability and times it by how many times they're doing whatever they're doing. Rolling a dice, flipping a coin, pulling out hats from like something from a bag, whatever. Okay, you take probability times by the number of times you do it. That gives you an estimate for the number of times that event will happen. Okay, so you need the probability that it lands on a 6 times by the total number. You should also relate relative expected frequencies to theoretical probability. So theoretical probability would be, again, something like when I do flipping a coin, the theoretical probability of me getting a head is 0.5 and the theoretical probability of me getting a tail is 0.5. Now, if I flip a coin 100 times, right, it's, again, theoretically I get 50-50. But what if I got 60 heads and 40 tails? Okay? The expected frequency is just the probability I get a head based on experiment. So it'd be 60 out of 100, which is 6/10, right? Which is 3/5. So the theoretical probability is a half, but my actual result shows that the probability is 3/5. Okay? So when it says relate them, the relation is that as I increase this number up here, I will get closer and closer to the theoretical probability. So this is where it's a bit weird, right? If I flip a coin 10 times, it's actually not that likely for me to get 5 heads and 5 tails, right? Even though theoretically I should. If I flip a coin 100 million times, my probability is actually a lot closer to 50-50. Okay? So in general, the expected frequency will get closer to the theoretical probability as you increase the number of trials. And what is the probability scale from 0 to 1? Well, probabilities are a decimal between 0 and 1. 1 means it's guaranteed, 0 means it's physically impossible. So let's say I have a coin that has heads and tails, and I say, okay, what's the probability of me getting a head or a tails? 100%, it's 1, because it's guaranteed that I get either a head or tails. Okay, and what's the probability that I get a triangle? 0, because there's no triangle on a coin, okay? Apply property that probability of an exhaustive set of outcomes. Okay, that's very fancy. But basically, all this is saying is all probabilities add to 1. Okay? So what does that mean? Well, if you look at this question on the right, in a bag there are only red, blue and white counters. Okay? So this is the exhaustive set they're talking about, right? I don't care about yellow, green, turquoise counters. I only have red, blue or white. So if I put my hand in a bag and I pull out a counter, the only possibilities are that it's red, blue or white. No other colour. So logically speaking, right, the probability of getting red plus the probability of getting blue plus the probability of getting white should add up to 1 because it's guaranteed, so it's 1, right, that I get one of the 3 colours. Yeah? So to work out the probability of getting white, all I'd do is do 1 minus 0.5 and 0.3, which is 0.2. The other way to do that, by the way, is to add 0.5 and 0.3 together and then subtract that from 1, right? So 1 minus 0.8. Cool. And then again, we did speak about this a bit earlier, right? If it's, again, assuming that your experiment's good, as you increase sample size, your actual empirical probability will approach the theoretical probability. So a question that they normally ask is, you know, this person's doing an experiment, right? They roll a dice 1,000 times and they get this many 1s, 2s, 3s, 4s, 5s, and 6s, or they flip a coin 100 times. How can they get a more accurate answer? The answer is always increase sample size. That always works as your answer because it will always make your answer more accurate because it will approach the theoretical probability. You also need to use Venn diagrams using sets and things like that, and also tree diagrams. So here we go. 40 students were surveyed. 20 visited France, 15 visited Spain, 10 have visited both France and Spain. Complete the Venn diagram. So here's what I do. I always start from the last piece of information, which is the overlap. So if there's 3 things, it will say 10 have visited France, Spain, and Germany, or whatever. So that gives me 10 in the overlap. So I've used that piece of information. Now it says 15 have visited Spain. I do not put a 15 here. Okay? Because think about it, right? 15 people have visited Spain. That includes the 10 people who have visited France and Spain. So everything in this circle should add up to 15. So this should be 5. 5 people have visited only Spain. 10 have visited France and Spain. So that gives me 15 people have visited Spain in total. Same thing with France. Everything in this big circle here should add up to 20. Okay, I'm done. Nope. 40 people were surveyed. 10 plus 10 plus 5 gives me 25, which is not 40. That means everyone else didn't visit France or Spain. So there's going to be another 15 people, because 15 plus 5 is 20, plus 10 is 30, plus 10 is 40. Every number inside your Venn diagram should add up to the total number of people. So in this case, all of my numbers should add up to 40. Okay, Tina has 2 bags of counters, bag A and B. She has 5 red and 3 blue in A, 4 red and 5 blue in B. She takes a random counter from each bag. Complete the probability tree diagram. Okay, so first of all, with bag A, there are 5 red and 3 blue. So the probability of getting red is 5 reds out of how many in total? 8 counters. Now, probabilities, a long tree should add up to 1, which makes sense, right? The probability of getting blue is now 3 over 8. And they do add up to 1. Bag B, okay, cool. We have 4 red and 5 blue, so it's 4 out of a total of 9. And therefore that's 5 out of a total of 9. And it'll be the exact same down here. And it says, work out the probability that Tina takes 2 blues. Well, it's going to be this probability followed by this one. As you go along a probability tree, you multiply, okay? So that's going to be 3/8 and, so times 5 over 9, like that, okay? So that'll be over 72, 15, okay? Which you can simplify to 5 over 24 if you'd like. So again, across branches should add up to 1. Along branches you always multiply. Construct theoretical probability spaces for single and combined experiments with equally likely, blah, blah, blah. Cool. Helen takes a card at random and she does not replace it, and then she then takes another card. Calculate the probability that both cards have the same number. So here are the possible outcomes. She takes 1 and a 1. Right? She takes 2 and a 2. She takes a 3 and a 3. Now, here's the key thing. This is the 3 possible ways she could have 2 cards of the same number. So my total probability, I would have to add these up, right? Because the probability she takes 2 cards of the same number would be the probability of getting 1 and 1 so essentially I'm going to use the word or. So probability of getting 1 or 1, or 2 and 2, or 3 and 3. And when I say or in probability, I mean add, okay? So probability of 1 and 1, add the probability of getting 2 and 2, add the probability of getting 3 and 3. So let's work that out. So, what's the probability of getting a 1 straight away? Well, there's 1 card, and there's 7, well, there's 2 1s, right? And there's 1, 2, 3, 4, 5, 6, 7 cards in total. So it's 2 out of 7 to pick a 1 at first. Now, she doesn't replace the card, so she has this 1. So let's say she took this one here. Yeah? What's the probability of getting another 1? Well, there's only 1 1 left. And there's 1, 2, 3, 4, 5, 6 cards left. Do the same thing for 2 now. So what's the probability of getting a 2 at first? Well, there's 2 2s out of a possible 7. When I've taken a 2, there'll only be 1 2 left out of 6. right? Because again, I'll take one of the 2s and then there's only 6 cards remaining. Lastly, how many 3s are there? Well, there are 3 3s, so it's 3 out of 7 at first. And then I've taken one of the 3s away, so now there's 2 out of 6 3s. And you'd add those all up, okay? Again, if you ever get a fraction that's bigger than 1, you know you've done something wrong. So let's work this out. We have, it's a bit tedious to put on a calculator, but oh, kind of hard. Keep in mind I'm using a keyboard and mouse to do this. It's taking me a lot longer than it should. On an actual calculator, I can do it a lot quicker. But I want to show you guys how to enter this in, because remember, I'm using brackets, and even when it's very painful for me to type it in, I'm still using brackets because you can make easy mistakes, and your calculator might do something a bit stupid if you don't put brackets on there. Gives me 5 over 21. So it's not that likely, which does kind of make sense. Part 8, calculate the probability of independent combined events using tree diagrams. So again, you're going to do the exact same thing with a tree diagram, and then you just need to work out probabilities. We have done a question exactly like this before, so feel free to pause the video and have an attempt. Calculate and interpret conditional probabilities using two-way tables. So two-way tables look like this. So we need to be able to work out what these gaps are. So completing it is quite interesting. So these total here shows me that 52 plus something gives me 100, so that must be 48. Now everything along this length should also add up to 48. So 22 plus 8 is 30, so that means this must be 18. So now I can work out this value here. 15 plus 18 is 33. 33 plus 19 plus something gives me 100, so 33 plus 19 is 52, so we need another 48. So that means that must be 26, and 15 plus 26 is 41, so I need another 11 here. Nice. One student is picked at random, write down the probability that they walk to school, so you take the total here, 33 out of 100, which I wouldn't simplify it to a third, although you can argue it's a third. And that gives us to the last topic, which is statistics. We're almost at the end of the video, thankfully. This has been pretty long. I mean, I'm pretty sure you can see the lighting change in my room because sun's setting and clouds and stuff. So S1, the first thing you need to be able to do is infer properties of populations or distributions from a sample, whilst knowing the limitations of sampling. So I'm going to go through what the limitations is. I can't really give you a good example of the properties because it's so different every single time, right? But the limitations is always that the sample may not be representative of the overall population. Okay, so the idea is that the sample is too small. The best sample is everyone. Okay, so whenever you see questions like that, where it's like, what are the limits or how can it make it better? Increase sample size, and the reason is that the sample may not be representative of the population. Here you need to be able to construct various different diagrams and charts and stuff, so I think the hardest one is probably pie chart. So what did Fiona spend the most money on? Rent and bills. What fraction was on transport? Well, it's 90 degrees, so it's a quarter. She spent £320 on transport, and we know that that's a quarter of her total budget. So 4 times that is her total budget, which is £1280. So how do you draw a pie chart? Well, again, I won't be able to draw it because you need a protractor, but I'll tell you the method. Here's what you do. You add up all 3 of these numbers, okay? So 58 plus 33 plus 29. 120. And what you want to do is work out how many angle, or like what degree does each person get. Because keep in mind, we have 360 degrees in total. So these 360 degrees need to be split between 120 people. So each person will get 3 degrees. I will then add another row or column, depending on how it's laid out, called angle, where all I'm going to do is times each of these numbers by the angle each person gets. So 58 times 3 gives me 174. 99 degrees, and then 87 degrees. To check your answer, I would recommend adding these three values together and making sure you get 360. And then all you need to do is actually draw the pie chart. So you would put your protractor along this starting line, where it will be 0, and you measure out 174, which would be something along the lines of this. Again, this is not accurate for French. Then you put your protractor along the line you just drew, and you measure out another 99 degrees, which again is going to be something vaguely like this. Now you don't actually need to do the last one, because it's just going to be what's left. But what I'd recommend doing is putting your protractor along this line and measuring 87 degrees and seeing if you get back to your starting position, okay? You need to be very accurate. But remember, your 0 line is just the line that you've just drawn, starting from this line. So 0 is here, then you move it over to here to draw German even, and along here to do Spanish. Now, if you look here, the pie chart below shows information about the languages studied by Year 11 students, and Maggie says it shows that more students study French, right, at school B. So if you look, it would be more, right? Well, not quite. Is she right? The answer is no. Pie charts do not tell you how many people study something, right? All it tells you is what fraction of people study it. So here, over half the students study French, and here just under half the students, right? But how do I know how many people are in Year 11? There could be 100 people here and 500 people here. So just under half of 500 is 250, just over half of 100 is, let's say, 60. So more people are actually in the first one. So here's the hint. If they ever ask you this, you can't tell, because pie charts show you proportion, not numbers of people. You also need to be able to do histograms. Okay, how do you work out histograms? You add another column standing for frequency density, FD. To work out FD, you take the frequency and you divide it by the class width. Okay, so you're going to be doing 20, and the width of this class goes from 20 to 30, so it's divided by 10. Right? That's 2. The next one, the frequency is 22. The class width goes from 30 to 35, so you divide by 5. 4.4. Next one, 16. Divided by the width, which is 5. 3.2. 13 divided by the width, which is 10, which would be 1.3. And 9 divided by the width, which is 15. I can't really do that in my head. 0.6. Okay, I probably could have done that in my head. Okay, now for a histogram, the height, if you want to call it that, the y-axis is the frequency density, and this would just be whatever your thing is. So in this case, it's age, right? And I'm going to start at 20, and then if you look each big one, it needs to go up to 65. So 30, 40, 50, 60, 70, that works perfectly. So every big square I'm going to do is 10. So that means each half square is 5. I need to go from 0 all the way up to basically 4.5. So I could go up in 0, 0.5, 1, 0.52, 0.53, 0.54, 0.5. Okay, so I can literally go up in 0.5s. So I'm just going to call that 1, 2, 3, 4, 5. And here's how it works. You plot off the frequency, but you only go up until the max class width. So you might notice that all of the bars will be different widths, like you can see over here. And the height, so the area is proportional to how many people you've got in here, right? So again, the next one, it's only 5, so it's actually only going up to here in terms of width. But it goes all the way up to 4.4, which is, so that's 0.5, it would be 0.1, 0.2. Again, you would need a ruler for this. And if you notice, I'm actually drawing it coming off the coming off the previous bar. 35 to 40 all the way up to 3.2. You see the look of concentration on my face. 40 to 50 goes up to 1.7. And again, I've done a lot of these topics in my live lessons, which are uploaded on YouTube, so I recommend going back and watching them. And lastly, 50 to 65 is 0.6, so it'll be one above the halfway mark. Like that. Looks hideous, but yeah. So again, it should look, well, I mean, this isn't the answer, obviously, this is a different kind of histogram, but we'll go through this one as well. Shows the information about weight of pigs, whatever. 30 pigs weigh between 50 and 65, so between 50 and here. Right? Work out an estimate for the number of pigs that weigh more than 80 kilos. So what you do here is you need to work out what the frequency density is. So you're doing 30 over 15. So you know that this height is 2. So each square looks like it's going up in ones. Right? Like that. And we need to work out an estimate for the number of pigs that weigh more than 80. So all you do for that is you do the class width. So in this case from 80 to 85 times the frequency density, which is 4. So 80 to 85 is 5. So 5 times 4 is 20. So there are 20 pigs between 80 and 85 kilos. And then you're going from 85 to 100, which is 15. So 15 times the frequency density, which is 1, which is 15. So in total there are 35 pigs above 80 kilograms in weight. There's some chunky boys. You also need to be able to work out a bunch of averages and also plot box plots. So here are the box plots. How do you do a box plot? Easy. The only things you need are the smallest value, the biggest value, and the 3 quartiles. So here's how you do that. So again, you're going to draw a line at 9, a line at 15. I tend to make it a bit smaller just to make it a bit more obvious that it's a box. 19 is the median. Again, using a ruler and a pencil would be way easier for this, but what can I say? There you go, that's my fantastic drawing. And this is compare the distribution. So what do you compare? You compare the median. So on average, people in class B scored higher than class A, because look at this line, it's further to the left. That's one set of marks. The second set is for doing spread. Okay, now you don't use the range, you use the interquartile range. So you look at this number here, 31 minus, I think that should 15, which is 16, right? So the interquartile range for the first one is 16. Interquartile range for the second one is, so it goes from 12 to 30, which is 18. So the spread for class B is bigger than the spread for class A. There you go, that's your full 2 marks. Interquartile range, compare. Median, compare. And then working out from just a normal list of numbers, the range, mode, and etc. Range is just the biggest minus the smallest number, so 7 minus 2 is 5. The mode is the number that appears the most, which is 4 in this case. There's 3 4s. The mean, you add them all up, and you divide by the number of numbers you have, which is divide by 10. You just use a calculator. Again, range, biggest minus smallest. Median is the middle number, so you write the numbers in order of size. This has already been done for us, and then you just kind of find the middle. So I like to cross them off one by one, circle it, and again the mean's the same. So applying statistics to describe a population, it's very similar to what we did with the box plots. You want to look at the average and you want to look at the spread. Average, you can use mean, median, or mode. Normally you use mean or median. And for the spread, you use range or interquartile range. Lastly, use and interpret scatter graphs of bivariate data. Bivariate means that you have 2 variables, so biology and physics in this case. And recognize the correlation, and no, it does not imply causation. Draw estimated lines of best fit, make predictions. Okay, cool. So what type of correlation? Well, if when you draw a line of best fit, right, it's not bad. If the line goes up, it is positive. In this case, it goes up. If the line goes down, it's negative. And if the line is basically horizontal, there's no correlation. Another student scored 52 marks on their biology test. Estimate their physics score. What you do is you look at where 52 is on your graph, on your x-axis. You would go up until you touch your line of best fit, and then you'd read across to estimate their physics score. And that is the end of AQA GCSE Maths. Edexcel, you'd also kind of benefit from this as well. But good Lord, we are finally finished. Best of luck on your exams.